So welcome everyone. This is my mastering the curl command line session. And I'm doing this here today, August 31, and I'm streaming it live on Twitch, so hopefully there's an audience there. I'm, of course, as I think you know, I'm Daniel Stenberg. I'm the lead developer of curl. I started the curl project a long time ago. And I'm here today. I work for Wolf SSL. I work full-time on curl. I'll get back to that a little bit, but today I'm primarily going to talk about some things I forgot about this slide, of course. So if just want to mention that I work on curl full-time, and that's possible thanks to me working for Wolf SSL. We sell support, commercial support to customers who need and want help with curl. So the setup we have today is I'm going to talk about curl for a long time. So basically, sit back, put your feet up or whatever. This is live stream. We have a chat room here that's of course not visible on screen, but this is going to last a while. I have a lot of slides here. I have a lot of content I want to go through. You will see the agenda in a few seconds. I'm doing this recorded, of course. That's why most of you are going to see this recorded after the fact. And I just wanted to mention to the live audience that sure, this is going to go on for a while. So take a pause and come back if you feel you have to and you want to. And this is a lot of materials I have never previously presented or talked about before. I've done a lot of new slides for this, so bear with me if I sort of sometimes might not remember exactly what I was going for. And I'm of course going to try to use the terminal in several occasions as well, bring it up and show how to do the command lines live. I will type, I do the curl command lines, and with all my fancy typos and everything. And this is how I intend to spend my next 2.5 hours or something. That's because that's my projected time. We'll see later how far off I am. And of course, again, this is recorded, but we're doing it live. So there's a live chat here. It's non-visible, but if you're in the chat room, feel free to ask questions, and I will try to get it into the presentation if I can, and if I manage to actually monitor the chat. The slides will be available after the fact as well, if you prefer to see them. There are a lot of them, but you might want to, follow along later when you rewatch it or whatever. So this is where I want us to go today. So starting out, just some words about the project, the curl project. What is the project? What is curl? How did it start and everything? And so from the ground up, I always talk about internet transfers, and at least in my family and my non-nerdy friends, people don't really know what an internet transfer is. I'm going to try to just get into that before I start talk about command line basics, the basic fundamentals of command line parts when you use curl. Pretty much I'm going to show you how to use options, how the options are constructed, options URLs and things like that. And then once we have laid the groundwork there, how options work, we're going to go into some of the more basic functionality and how you use those options to do things, upload, downloads, and all sorts of fun things. And when we have covered the basics, I will go even deeper into some details around how to do TLS and then options around TLS. There are a lot of different things you can do there, of course, and then a similar thing, a lot of different proxy options, what proxies are, how they work, and different options around that. And then HTTP being maybe, well, it is the by far most commonly used protocol when you use curl, and I'm going to spend a significant amount of time to talk about how to do curl stuff to play with HTTP and HTTP features, really. And then by this time everyone is going to be really tired and fed up with me, but then I'm going to just mention a few details about FTP, because FTP is a protocol that stands out a little bit for some, for reasons I'm going to get into. Now, that's a fairly short section, and then before we all die from exhaustion, I'm going to talk a little bit about curl coming up next, the future, what's going to possibly happen or not. So all of that, a lot of stuff, a lot of slides. Take it easy, lean back. So the curl project, as you can see in the lower right corner here, I insert a little counter here every once in a while to just remind us that where we are in this journey. So the curl project is actually something that started a long time ago, right? So back in November 1996, I found this project called HTTP-GET. It was not written by me. It was written by a Brazilian guy called Rafael Sagula, and he had created this. He released that first version, 0.1, in November 11, 1996. I found it. I used it to do download currency rates. That was 160 lines of code, C code, and that taught me that was really easy to do a really small HTTP client in C, HTTP 1.0. I sent back some patches. Rafael grew tired from me, my patches, so he said you can take over maintenance of this tool. So I became the maintainer, continued working on that. I added more protocols, go for an FTP. And in August 1997, we renamed this tool to URL get instead, because it wasn't just HTTP anymore, it was now Gopher, and then we added FTP as well. So, and then after a long time, we added upload support as well, and we renamed the project again. So in March 1998, we shipped curl for the first time. By then, we called it curl version 4.0, because we kept the version numbering from the previous ones. And curl in March 1998, that was 2,400 lines of code, 24 command line options. 2 years later, we changed a lot of the internals, remodeled everything so that we could provide the networking stuff as a library instead of just the command line tool. So now most of the stuff turned into this networking library, and then we made curl just a small wrapper for accessing libcurl from a shell, really. So the name, right? Lots of people then ask me, so why is it called curl? But naming is really hard. What do you name something? What do you call something? But yes, curl, the previous version names I mentioned, HTTP GET, URL GET, they were sort of references to protocols and getting things, and they all eventually get things with URL. So I wanted it to be something with URL in the name, and then the C could be for a client. I also wanted it to be short so that you could type it easily, as you would with all Unix command lines. Command line tools, you don't want it to be long because it's tedious to type. And I wanted it to be pronounceable and an easy word to say in many languages, in primarily than in Swedish, my language, and English. So curl, excellent. It's easy to say, it's easy to spell, it's easy to type. And I also like that you can actually if you would separate the URL from the C, you could also you could say it C URL, as it would like the cat command, but for a URL. So instead of a file, it would be a URL, pretty much. Others have done, after the fact, we also found out some other fun ways you could actually maybe spell it out, the acronym curl, but those are just, funny ways to invent new ways to explain the word. In the curl project, then, of course, project is a fun thing to call it, because a project usually in most other aspects actually have a limited time scope too, but the curl project is of course an open source project. It will never end. So we do two primary things in the project. We do, as I mentioned already, the command line tool and the library. They do internet transfers as a client. So we have a few golden sort of rules that we don't deviate from. We only do client-side networking, so they're curl and libcurl, they're always client-side, no server-side stuff. really. And there are or about internet transfers. They're supposed to be upload or download or both, but if they're not strictly upload download, that's probably not curl materials. And of course, they should talk about an endpoint specified as a URL, and then a URL should be a standard or a semi-standard or at least an attempted standard to exist. The syntax. I could also mention that, of course, all the URL schemes that curl supports, they are all actually of the :// style, right? So hence the :// in the logo, because that's all the URLs that curl supports, they all use ://. Curl and everything we do is open source. Open source means that everything is there to be used openly, shared and distributed by anyone. We also make every discussion, decision, everything held in the open, and we do that to as much as we can. Curl is MIT licensed. It's not exactly the MIT license, because someone at some point decided that he should change the edit the license a little bit. I did. I don't remember why. It was stupid, but it's not a word for word MIT license. It's actually slightly edited, but it's essentially the same content. It's short and sweet, and this is how it looks if you just read all the words. It's 200 words or something. Easy peasy, nothing strange. The MIT style license. Pretty much you can do whatever you want, as long as you have this copyright notice somewhere in your product or documentation or something. It's a very, very liberal license. The curl project, we make these projects, and it's open source, and it means that it is developed by everyone, or everyone is encouraged and welcome to change, submit bugs and submit features and do anything. I'm the only one around in the project who actually works on this full time. So a lot of people are helping out for different reasons, paid by others in different ways. So anyone can provide their changes or proposals. There's no paperwork. We don't have any. You don't have to sign any contracts. There's no CLAs, no license agreements. We of course review and test everything that is proposed before we merge and accept them. But otherwise, anyone can participate. There's a small team of people who can accept the merge changes. It's certainly not just me, where I think we're maybe 15 people who have the rights to do it and the ability. We do releases. Of course, we have done a lot of releases. So, as I mentioned, the first HTTP GET came in 1996, the first curl in 1998. So for the last maybe 10, 12 years, we do releases every 8 weeks. On Wednesdays, actually. Wednesdays, 8 weeks, Wednesday, 8 weeks, Wednesday. And sometimes we do them sooner when we need to do a patch release. But we're looking forward to do our 251st release the next time, actually on September 13. So we've done it a lot of times. We release what's in the master branch at the time, meaning that we don't work on particular features, or rather we don't wait for features to get merged to do releases. We release on the clock, and whatever is done then we release. And so that is how we work, really. And that's why we also do this calendar-based release. So we have this cycle, 8-week release cycle. If you look at the right side, that's the release Wednesday, and then we go down, because after the release we have a 10-day cool down period during which we don't merge features, we don't rock the boat, we might merge bug fixes, we might do patch releases. And then after 10 days after that release, it's a Saturday, we open the feature window and we allow features to get merged for 3 weeks, 21 days, and then it's Saturday again. Then we close the feature window, we have 25 days of feature freeze, and then we do a release. And then we start over and over and over and over, and it never ends, and this is the schedule we stick to. We also don't break existing functionality, right? So if we have shipped features, we have shipped options, we have shipped something, it started to work at some version, we keep it working like that. We don't break it ever, really. I could possibly say that, of course, there's some asterisks there in the small print. So sometimes it does happen due to bugs or due to other unforeseen circumstances. But we make the utmost sort of, we put in a lot of effort and make it really, this is something we really work hard to live up to. Everything this is on GitHub. We work and sort of we go by the GitHub model really. So if you want to participate in the project, you've done that with other GitHub projects, you know how to do it. You submit issues when you have a problem. We do pull requests. You basically go to GitHub, you fork the repository and you do your changes and you submit the pull request. Easy peasy, low friction, low bar. So basically we do our best to make sure that it is easy to participate and easy to contribute when you have something. And there's a lot of documentation, so if you want to learn more, I'm going to dig into a lot of things today, but you will of course feel that I'm not going through it enough, but we have a lot of documentation. So of course you can just start with the man page, man curl, also built into the tool itself, curl -- manual. You can go to the web page, which is always the latest version of the man page rendered online then. So if we have corrected the man page since your version, this is the more up-to-date one. And then there's this book, Everything Curl, which is online. That's the image here. That's the front of it. That's more than 100,000 words in that thing now. It's a lot of words, a lot of documentation. And of course, the more you do curl -- help to get suggestions of what options to use. And if that is not enough, there are of course ways for you to ask for help, because of course there's a huge community of people using curl, people who know to use curl, and others who are asking for help, and we can all help out each other, right? So we're an old project. We do things by mailing lists. We have done that since the 90s. So we primarily have the curl users mailing list, focused to command line tool questions, command line tool users. It's there on lists.hacks.se. curl users, and there's another one called curl library, which is more focused on the library than development, debugging, sort of more architectural stuff, more source, more development. And it's also on the same site. And of course, if you rather go with just discussing things that aren't really bugs, but you don't want to go mailing lists, you can use the discussion feature on the GitHub project. On the GitHub project repository thing, curl /curl blah blah blah. And if you want to pay for help because you run this, you do this as a part of a business, we're here for you to help you as well. So just get in contact with wolfSSL and we will help you immediately. So basically, curl then, this is what the curl project has then accomplished during all this time. We support a busload of stuff. That's why I often use that Swiss Army knife symbol or toy image of curl, because it has so many different toggles and things that you can, levers and things to do. And curl actually literally runs everywhere. You can of course use it on Linux and all the Linux distros. It's default in Windows, it's default on Mac. You can run it on all those fun BSDs, older legacy systems, VMS. You can on anything. I actually have this collection of operating systems where people have mentioned that they use curl on or ever ran curl on, and it's this amazing set of 92 different operating systems. Many of them, we never knew existed as an operating system, but it's an amazing number of them. And of course, all of this, as I said, it's a lot of people helping out. The top blue graph plot here shows the number of committers in the project since the beginning, soon reaching 1,200. Committers being someone who has authored code or a part of something that has been merged into Git. And just counting people who have contributed, that number is approaching 3,000 soon. that also then includes people who have reported bugs and so on. Number of lines of code is a fascinating growth. As you can see, in 1998, 2,000 lines of code, and now 160,000 lines of code. So 80 times growth roughly in 25 years or so. So the project has really then come to this point where we count roughly maybe 20 billion installations worldwide. It's really, really hard to know. It's a guesstimate at best, but it's everywhere. And yet, of course, the simplicity of the tool and really, I think the straightforwardness of the API has made, of course, it makes it simple to. It looks simple. It's easy to think that you can sort of, re-implement this in a few days, and people keep thinking that. But I really want to say that one of our goals with cURL has always been to make sure that everything that worked before still works, right? So even if you still use this, you used it 10 years ago, you use it today, it still works the same, it still looks the same. In some cases, you don't see the development because it looks the same, it works the same to a large extent. Anyway, that's just sort of, that's the cURL project. That's what we do. A small project, lots of people, lots of installations. We do internet transfers. And what is an internet transfer? This is so fun because I just want all of us, or any reader here, to sort of follow along what we're talking about here, because an internet transfer is, first we're talking always. When we talk about cURL, there's a client and there's a server. The server is the remote machine somewhere. cURL is the client. We're here, basically. So we connect to the client. The cURL client connects to a server somewhere else, usually somewhere remote, perhaps, to do an internet transfer. So we send data. It's a stream of data to the server or from the server. That's the internet transfer, right? And if we get data from the server, it's a download. If you send data to the server, it's an upload. It's not that strange, but a little bit of what I got into before also, that the data can be anything and cURL doesn't really know. So text, images, maps, code, film, sound, cURL doesn't know and doesn't care. Everything it sends, it just sends it because the user asks cURL to get the data or send the data. It doesn't know what the data is. So, and then I use this little image here to show my view of what a transfer is. And I also want to introduce these tiny images, but I'm going to reuse these icons in some other slides as well. So the bottom thing here, the client, that's the cURL, right? That's a cURL logo. It doesn't have to be a laptop, of course. It could also be a phone, a car, a fridge, a printer, and it usually is, or a television set, or a game console, or anything that runs cURL. But we're talking cURL command line today, so command lines usually run by a computer thing, so the laptop is a good symbol for that. And it uploads things to the server. I show that as a cloud because the servers are sometimes in the cloud, right? Downloads things from the cloud down to the computer. That's a download. So cURL then supports a lot of protocols, right? If counting them like this, there sometimes you can count them to as 28 if you separate the S versions from the non-S versions, and they all do uploads or downloads or both or one of them in this fun combination. It doesn't really matter. I just want to show you that there's a mix. Some of them don't do uploads, some of them don't do downloads, and things like that. There's a telnet here on line 4. It doesn't really do either because it's a weird mishmash of things, but let's forget about that right now. I just wanted to mention that there's this mix. Upload, download, upload, sending things up to the server, download, getting things down from the server. And all of these protocols, as you can see, there's a lot of different things here with that S in parentheses at the end. S being for secure, and that is of course for the secure protocols, authenticated versus unauthenticated protocols. When cURL started, there were basically no authenticated protocols, and over the time we pretty much all go to more and more authenticated protocols. And of course we all want and emphasize and encourage everyone to use authenticated protocols, and that means using TLS or SSH as the sort of the underlying protocol, because authentication well, yeah, exactly, that's all of these S protocols and SCP and SFTP. And when you do that, of course, don't switch it off with the insecure option. curl provides this option that says, sure, go ahead, run it insecurely. But if you do it insecurely, yeah, that's insecure. Don't do that. It's -k in the shorter version, but we really strongly suggest you never do that, because if you use unauthenticated transfers, like HTTP without the S, it can be eavesdropped and it can be tampered with, and curl or the user using curl won't be able to tell when that is happening. It's also then easily attacked in different ways, so we really should avoid it. We should try to use authenticated protocols as much as possible, TLS or SSH powered protocols. So that is internet transfers. Right, so now already on slide 33. So that's 20% in after half an hour. Jesus, I need to speed this up. Here we go. So there's a command line. The curl is a command line tool, right? How do you use a command line tool? The command line, of course, when we started this, command line tools were perhaps more commonly used and a little bit more like every day, and then over time we use it less and less. But curl is still a command line tool, and it's a very powerful command line tool. So of course, first you have different ways to specify options to the command line tool. You can do short option, -V, for example. That's just minus and a letter. That's how you spell a short option. There are a lot, basically all the letters, both lowercase and uppercase, are already used, and several digits. So there are a lot of short options. You can specify long options. They start with 2 dashes. -- version, for example. There are all the short options also have a long version of the same options. So that V in the short version is called the -- version in the long version. So there's always the long version. There's sometimes the short version. All the long versions start with 2 dashes. All the short versions start with 1 dash. Pretty simple. Some of the options, or a lot of them actually, are just Boolean. You just put them there. It's sort of, it's enabling this. Here's an example. The path as is option. It switches it on. It's like a light switch. We switch on the path as is. We want curl to do path as is. Use this option, and then you can do some of the options are not Boolean. They take arguments. Like I want to store the output somewhere. Then we have this -- output option and a space in between, and then the output, the argument to the option. In this case, store.html being the argument to the output option. Yeah, you follow along. If you want to do them with spaces, you usually have to do them with double quotes around them, because otherwise the shell will do something else for you. And when it comes to quotes around this, I think I will use double quotes mostly here in my examples, because that works better also on Windows and Linux. But they're not fully equivalent, of course. So, but that's more of a shell thing. So I encourage you to read up on the differences between double quotes and single quotes if you're on non-Windows shells, and if you're on Windows, don't use single quotes, because they won't work. And of course, all those Boolean options, like the path as is, you can sort of switch it off again by prefixing the option name with with the no instead. So -- no path as is switching off the light again, pretty much. So all the long Boolean options are like that. And if they're Boolean or not, it's not visible in the name. You have to actually read the man page to figure that out. And of course, all these options are usually, standalone. They just change some things. So if you want to change more things, you add more options. So you can add a lot of options, on, off, different arguments. So this basically makes it a crazy amount of combinations when you add all of these options. And there are many options to select from. And, you can read the documentation and find it out for yourself, but there's a lot. And the availability of which particular versions will depend on, which particular options that are available will depend on your particular version that you have installed, because we keep adding new command line options all the time. We add them at the rate at about 10 per year. So yes, today we have, when I'm talking to you today, we actually have 257 command line options. If you wait a little longer, we will have more. So sure, and depending then on which particular release you go with, you will have a different amount, a different set of options available. And I just have to say that it's an error on this slide. So yes, that variable in write out, it doesn't exist. Path as is, I don't know. It's a mistake in there. Mistakes are fun. Okay, so availability will depend on version, and it will depend on particular build, because different builds you can select to enable different things, and they will run on different platforms, and they will also use different third-party libraries. So if you go with curl on different places, it might work slightly differently depending on different things. They all are there, so they should be possible to have there, but you know. And as I said, the number of options, command line options in curl have increased over the time. So it started out 24 in 1998. We have 257 today. It's not a good thing to have a lot of options, but we add them because we have features that we want to provide. So URLs, curl works with URLs, right? I mentioned, see the client for URLs. So this is a typical, this is not a typical URL, but this is a URL with a lot of different components, and I've used sort of change some colors to make sort of highlight the different components of a URL. The URL that curl works with is specified by the standard called RFC 3986, and strictly speaking, it's a slightly patched version of that. But anyway, that's our guide here, is this RFC that says how an URL or a URI really should work. Okay, so basically, for example, you don't use a space anywhere in the URL because a URL cannot have a space. You use %20 instead. And as a special thing, curl can work with URLs without schemes. That's not really a URL anymore because a URL has to have a scheme, but curl still supports it. So basically it means that if you can, for example, just provide a host name, and just that host name, curl will then just guess what kind of scheme you meant, which usually means it guesses HTTP. And of course, you can provide a user and password in the URL there. So if you do that, you have to remember to URL encode them if you have some funny letters in there, for example. And the host name, as you can see in the example up there, it says @host. That's the host name that you want to connect to. That's the server. The name of the server could be name, like just ASCII letters, or it could be an international domain name. It can be an IPv4 address, or it can be an IPv6 address, like this, right? The very simple example. Here's the most basic URL you can imagine, example.com, https:// example.com. Or it could be, they could have the IDN name. This is I really cannot pronounce this, but this is a genuine Taiwanese domain name. It's an IDN, of course, so curl will understand this and convert it internally to be able to work with it, and it works fine. Or you could specify the IPv4 numerical address, or you can just specify the IPv6 numerical address to the target server. Curl, of course, supports all that. If you would leave out the scheme part, the name : / from all of these examples, curl would then guess what you meant. In most cases, it guesses HTTP. There. Anything that is not an option is a URL. So if you don't start with a dash or a dash, right? So if it's not an option, it is a URL. Meaning that's the only thing you can provide to curl, right? Options and URLs, options and URLs. There's nothing else you can provide. Options and URLs. You just select which. Well, you can also select to not provide anything at all. Just provide the curl command line. Like if you go like this, and let me pop up the terminal here. So here's the terminal, right? So if I enter curl, no options at all. Yeah, right. So that's the most bare minimum, right? So the next bare minimum might be to go with curl localhost. Again, no scheme. It'll guess what it is. It will guess HTTP. So it'll connect to my server on the host name called localhost, and yep, it downloaded HTTP, spewed it out on the terminal. Yep. Or you can, as I said, the most basic things, of course, add an option like that one, which or the longer version, which is called version. So easy peasy. That's sort of just the basic command line parser and URL thing. When you talk about port numbers, of course, when you talk about URLs, you provide a port number. Port number is a 16-bit number, so it's from 0 to 65,535. In most cases, you don't specify which port number it is because let me hide the terminal. It sits there and in the way. Sorry. So usually you just provide the scheme name, right? So curl knows what port number it will use. It uses the default one. So you can set it in the URL like this. This will speak HTTPS to port 8080 at the example.com server. Yeah, or you can provide it with IPv6 address. Easy. So, but I just want to emphasize then that I said that URLs in curl works with this RFC 3986 style of URLs, and that is not necessarily always the case with URLs, right? And with browsers, and in particularly not with browsers, the address field in browsers. So if you go to your browser and you add stuff in the address bar in there, that's not necessarily exactly the same standard for URLs. I'm not going to get into that many more details. I just want to make you aware that there might be some differences, and it could be problematic sometimes. The browsers have their own URL standard that they follow, which is not the same as the one curl works with. And it's a bit of a sad situation, but the reality is that there really is no good global URL standard anymore. It hasn't existed for a long time. So there will be times when we run into the problems where when one tool meant something and the other tool did something else with exactly the same URL. Anyway, so you provide options and URLs to curl, right? Curl and the number of options and number of URLs. Any amount of URLs. Yes, it really means there's no limit to the number of URLs you can provide to curl. It might be a bit impractical at some point, but it's not up to curl to set that limit. So you can provide however many you just manage to do. So that also means, but when you provide a lot of them, or just two of them, every one of those provided URLs on the command line, they need a place to put the output, right? If you want to get one URL and then another URL, they need to end up somewhere. Like this. This example here, I will show you first a command line example. So it provides two URLs. You see one is example.com/file.et and the other one is curl.se/file2. You need two -o options. The lowercase o is for output file name, right? So as you can see, there are two of them because there are two URLs. Or you can, the order of them is not important either, right? So you could put them in a different order, but they still correlate to the same. So the first URL gets the first -o, the second URL gets the second -o. So you can mix and match. The order doesn't matter, but the order does matter because the second URL will get the second -o, but you can mix them like this. Or like this. This is a different option. This is the uppercase O, which saves the URL according to the file name part of the URL. So the first, the example.com/file1 will be saved as file1, and the curl.se/file2 will be saved as file2. Or you can just, send it everything out and redirect with a shell redirect, which means that both contents from both of these files will get into the same output, like the one called everything here. It's not that strange. You can also use if you want to use remote name all. It basically sets the -O automatically for all the URLs on the command line. So you can actually use one of that and then a lot of URLs, and it'll do the same for all of them. So you can, that's sort of, you need to provide options for every URL that you transfer, or you will get them on the standard out. Usually standard out is not what you want. Sometimes it is. You decide. So there's a query part in the URL as well. As you can see, the query part is the little thing that comes after the question mark, right? Before the fragment part. The fragment part is never sent over the network at all, so we can usually, well, often we don't talk about the fragment part when we speak curl because it's not sent over the wire anyway. So queries, or the query part, they're often created like name value pairs separated by ampersands. It's typoed. Okay, so basically you provide a set of pairs, right? Name is Daniel, tool is curl, age is old, with a separation like that. So this is, it's not, you don't have to do that, but it's a very common thing to do. It's more or less a sort of a semi-standard de facto thing. This is how basically a huge part of the internet or the web is made, right? And you can, in curl then has this fancy option called --URL query that will add one of those pairs to the query part of the URL. So you can do name equals Daniel and it will add that to the query part in the URL, or you can add a whole range of them and they will and curl will add them automatically to the query part, which helps you create that particular URL you need to work with. And it then gets URL encoded suitably to work correctly. URL encoded meaning then that it encodes it with a character set and percent encodes it if it needs to, if it would contain some other funky letters that otherwise couldn't work in a URL. And you can also read contents from a file and so on. So it helps you create that query if you want to do query things in your script. For example, like this, if you go to example.com but you want to add a query that says name is Daniel Stenberg, and I used this example just because it has a space in there, so the space will be URL encoded. I also then want to mention, talking about URLs, this is not curl at all. This is a companion tool to curl that we created earlier this year. It's called cURL. It is a tool that parses and manipulates URLs. And it's there to help you create, fiddle, update, extract, manage URLs. You can, for example, if you have a URL but you want to change the host name, you have a URL but you want to sort of, what is the new URL if this URL would redirect to this relative URL, or why not change the port number URL? How would it become then? Basically, it is a helper for your shell scripts to let you fiddle with URLs without parsing, understanding URLs yourself. This tool understands and manipulates the URLs for you. You can also, like things, add stuff to the query string. Again, just as I mentioned, this particular tool can do that as well. Or you can make it output as a JSON object, or you can extract particular part from the query string. Super handy when you write scripts or command lines when you want to interact or sort of manipulate, update, extract things from URLs. Yeah, I just wanted to mention that, so you keep that in mind. Try it out at some point. When curl works with URLs, it supports this concept we called globbing. I don't know really if this is a really good term, but we call it globbing. And globbing here means that you can provide ranges and lists sort of embedded in the URL. Primarily, basically like this. Here's a range, right? 1 to 100. So it means that instead of you writing this almost the same URL, 100 times and just changing a number, you can use this range instead within the URL. Or you can even have it 0 prefixed. You can make it letters like A to Z, or you can also even make it, do jumps. So 1 to 100 with take steps by 10 at a time. And you can even do that steps with the letters. And then of course you can do lists, which is, as you can see, this is using braces instead, and you have comma separated, so 1, 2, 3, or weak, like that. and you can combine them. So you can, for example, use a list and a range, and you can use these funny hash on the numbers to refer back to the name used in that particular glob part. So in this case, this will get 66 different URLs for you. Download them in different JPEG file names in your target directory. Boom. Kind of handy when you know that you have files or remote files, remote resources that follow these various kind of patterns, and you want to get them. And I want to just emphasize that then these, of course, can then do a ridiculous amount of variations if you combine them in endless and huge ranges. So yes, you can do a lot of them, and you can. Since then, this then uses these braces and brackets as a sort of magic letters. You can't use them as easily in URLs, of course. And this originally you could never use. They are sort of reserved characters in URLs, so they couldn't be used. So that's why I used them originally when I designed this feature. Years later, others have decided to go differently. So sometimes you will see URLs using these letters, and then you might want to go with glob off so that you can. Then curl will accept those letters as is in URLs, even though they're strictly speaking not supported. And if you provide a lot of URLs, maybe you don't want them to be done serially, right? The default way for curl to get URLs is one by one by one by one by one. Go through the list of provided URLs one at a time. But if you provide the uppercase Z or -- parallel, it will do them in parallel up to 50 at a time. By default, it'll do 50 at a time. So if you provide more than 50, it will put the rest in a queue until the first is done. Then it will pull from the queue to keep 50 alive all the time until there's less than 50 left to do. And you can also change that. Parallel max is the option to change to 50. You can go up to, I think 300 is max. It's capped because in most cases it causes problems in your system when you go up a certain level. Let's ignore that for now. And it works both up and down, of course. And you can also sort of tweak it a little bit, and you could go and say you prefer multiplexing or not multiplexing by saying I'd rather go multiplexing or not multiplexing by using this parallel immediate, which sort of changes the priorities for curl and how to do things. And you can do them in both directions. It's really handy if you have a lot of different downloads, and in particular if they're independent of each other, why not get them all at the same time? So when you want to list which options you have available to use, you use -- help. It will list your most important ones, I think, from sort of to start with, like this. Here's my output from before. Let's clear that. So if I do curl with typos and help, yep, these are the ones that we for some reason consider the most important, or maybe the most frequently used ones. So yeah, you can see those. That's not a too intimidating list or a large list, but you can also do then help category to get help or a list of options for a particular category. So if you would do it also says so here on the screen, right? So if you would use help category, you would see the categories that exists. So if we go help category, it will show us a lot of different categories that are available for us to list options for. So if let's say we want to get options, we want to learn more about file system output options, we would go help output. Not too many there either, right? So that's how you get options. So without getting everything, but if you want to get everything, you can also do help all, which of course is going to be a really big list. So if I scroll up, it looks like this. These are this is the version I'm using here does not have 257 options. I think this is 254 options, but who's counting? And of course, curl -- manual is a way to get to the manual. Basically, you do manual, and you can pipe it to something like less, for example, handy. And here is the man page, and now I can read about it. And then here comes the options. So append, AWS, blah blah blah. Of course, to make this really convenient, I would search for the options using something. So going further, if providing everything on the command line is not good enough for you, and sometimes it's not really convenient, those super long command lines. Sometimes some systems even have limited command line length, so you might run into the maximum command line length because you have 1 bazillion number of URLs and options and everything, so that it doesn't really fit on the command line. Then you can do these what we call config files, basically putting a lot of config files, command lines into a file. And then you just provide one option and its argument per line in a text file. There's the default one in your home directory. And you use it, otherwise you can use it just -K or -config in a file. And then that file will be read, and it will read command line options from that file. And you can of course also then read it from standard input if you want to pipe that into curl and have it read from that. And that, I know sometimes people then generate those config files, and they can be huge. Then of course you can put whatever you want in there, and there's now a 10 megabyte line limit in this config file, so you can put in a lot, and there's no limit to the size of the config file either. So it can just, or maybe there's you can. There is some limit, but you can at least put a lot of stuff in there without running into problems. And I just want to then come. Sometimes, of course, when you want to do some things, you provide passwords to curl, and passwords, credentials in general, will of course sometimes be a little bit sensitive. You provide -u name : password when you want to provide your credentials so that you get that resource that you want to, because it's password protected. There's also this other .NET RC file that I'm going to mention in a second, and you can provide passwords in config files because, as I said, they're command lines in a file, right? So you can put a -u in one of those. But you need to remember that, for example, there's a local leakage in that if others are running, if you have a multi-user system, there will be other users on your system, and they might do a process listing, right? They could do PS or whatever it's called on your system, and see your command lines maybe switch, passing by in the process list. That process list then might contain curl -u and your password. You really need to be aware of that. Curl tries to hide them, but it doesn't always succeed, and there's always sort of a risk that it leaks in there anyway. And of course, when you're using networking, which you do with curl typically, right? There's also this that you will send the credentials over the network. And if you're then using unauthenticated network protocols, the passwords will be sent in the clear, right? So anyone who is on the network can snoop on the network, can then perhaps see your password fly by and steal it from you and abuse it in whatever ways. And there's also this, just as a sort of heads up, remember that if you show curl logging, tracing, debugging outputs, they might also contain credentials. So remember, keep track of your credentials and make sure that you use authenticated protocols always, and don't leak your secrets. When you download stuff, and in particular when you transfer things that are somewhat large, it's usually sometimes handy to do progress meters, so that you see that something is happening and you can figure out how long time you have to wait until it's done. So unless you use this -s, -silent, or this no progress meter options, curl will show you this is a download in progress, and it shows % of the transfer, in % and in total amount of data, how much it has received, what's the average download speed, the upload speed, the total amount of time that it estimates that the transfer will take, how long it has been going on, 4 seconds in this case, And how long time it's left? 4 hours, 41 minutes and 39 seconds. It's a slow transfer. And the current speed, 9,287 bytes in this case, which then of course is a rather slow transfer nowadays. So this is how it will show them, of course, by default, if you download a file. If you choose to instead use this #, hash sign, whatever it's called, the progress bar option, you will instead get this progress bar thing that will go from up to 100%, and then you're done. If you instead do parallel transfers, then of course these progress meters don't really work like that. Yeah, I should mention that the units up there, they are in bytes unless there's a suffix. There will be suffixes if they go, it will be kilobyte, K for kilobytes, M for megabytes, G for gigabytes, and there will be P for petabytes, and so on. So depending on your speed, it will sort of reduce the accuracy because it will always only use 5 character width in the progress meter above. So and when the same thing goes here. Here's another example. This is a transfer, 2 transfers in parallel, and in this case it has downloaded 12% of them. They have downloaded 34.5 gigabytes at the speed of 3,903 megabytes per second, and it's taken 9 seconds so far. When it comes to parallel transfers, it's harder for curl to sometimes know the total expected time and the total expected amount, because it depends on what it knows about all the transfer and usually what it doesn't know about all the transfers at that particular moment in time. Anyway, so it shows a completely different progress meter when you do them in parallel, because it needs to show one line of data for potentially a lot of parallel transfers. Another little fancy thing to remember is that I mentioned that all the URLs need their output options, right? And basically there's a lot of things in the curl command line tool that sort of adds stuff up and then works on them, which means that sometimes you need to put in a next that says stop it, work on this what you got, and then we reset everything and start over on the command line. And I'll show you a pretty good example. So for example, if you wanted to add headers to a request, I will get into exactly what that means later, but like in this case we can just see that it uses the $H option twice here, header 1, header 2, and there are 2 URLs. In this case it will actually add both headers to the request and then send that request to both URLs. So both URLs will get both headers. That's what the $H option does. That's what it means. But what if you want to send the first header to the first URL and the second header to the second URL, only one to each and different to each? Then you need the --next option, because it resets the parser. So then it just adds the first one to the first one, reset, create a new set of headers to the second one. This is very powerful, and usually you can forget about it. But if you want to do lots of things on the same command line, this is also a savior for you. So let's take a little sort of deep breath. That's a third of the presentation in 1 hour. So pretty good. Now I think we got into the basics, how to use the command line, options, URLs, parallels, and a little things about downloads and stuff. And now we're going to get into more stuff, how to do things with curl. Now we understand the options and stuff, and now I'm going to tell you more about particular options and fancy things we want to do with options. I already showed you curl -V or -- version. That's how you get to know the version of the particular curl you have installed, right? curl -V. I use the different colors here on the different lines just to highlight a little bit to make you see them better. The first line, curl -V, the first line there is a version number, curl version number the platform it's built for, the libcurl version number, usually the same. If they're not the same, that's usually a sign of something weird. And then a lot of different components that is used in this libcurl and their versions. So as you can see, OpenSSL, zlib, brotli, zstandard, libidn2, libpsl. A lot of that just tells the reader about version numbers of components in this curl tool. There's a release date. That's we can see that it's a fairly recent version, right? From July this year. It's a little bit over a month old, so it's fresh. Then what kind of protocols? Actually, these are URL schemes. So what kind of protocols does this version, your installation of curl, support? A bunch of them we can see here: dict, file, FTP, FTPS, Gopher, blah blah blah. And then maybe the most interesting one in many cases is this fourth line called features. These are just names, tags basically, for different features that curl can have or maybe does not have. It all depends on your version, your build, and your third-party libraries, and so on. So these ones will differ greatly depending on what build you're running, what platform you're on, what version of curl you have. So, but usually they when you have problems, for example, and you submit an issue to us, we will often ask you for the curl-v output because it contains all of this. So it gives a lot of details and information about the particular curl installation that you use or run. When you use curl, it does a lot of things internal, of course, and then we provide this verbose option, -- verbose or -v, just to help. It makes the transfer, the operation verbose. It speaks more. It tells more about what is going on. What does it do when it does what it does, right? So by doing that, we can get more information. When things don't go the way you want them to, don't go the way you expected them to, you add the -v. And adding more makes no difference. I know a lot of people like that and they use that because a lot of other tools in the world, they actually add more verbosity the more number of V's you add. But for curl, it doesn't matter. You can add how many ever you want because it's a Boolean. It will just add sort of switch it on many times. So it doesn't matter if you switch it on many more times. It'll just be switched on. And then if -v is not enough verbose, there's also these trace ASCII and trace options. I'll show them in a second. So they will just then make the even more helpful output descriptions available to you. Then we also provide this trace time option, which then makes a prefix to all lines with a time code so that you can, that's, for example, is good to see, is there a particular thing in time that takes time, or how fast are things, or whatever. And then a recent newcomer in the family is the trace IDs. That's also another prefix to the verbose output lines that outputs the prefix for the transfer ID and connection ID to help you identify which transfer and which connection are different verbose logging lines concerning. Try them out. You'll see the trace IDs are particularly good when you do parallel transfers. Trace time is particularly good when you want to identify what in a certain procedure is taking a lot of time or is not taking a lot of time, and so on. And again, be careful when you share these logs because sometimes they contain secrets. It doesn't have to be only credentials. It could also be server names or port numbers or content that you transported with curl when you did this. So when you want to do trace, you basically do this. Here's an example. This makes an HTTP post sending the 3 bytes moo as a cow, moo, to this server called curl.se that I happen to know about. So this is how it looks like when you start out. So you add --trace, and do you see this as --trace and the dash? It means sends the output to standard out instead of to a particular file. You can also save it to a file if you prefer. Usually saving it to a file is better because then you can sort of inspect it after the fact and scroll around easier. But as you can see here, it starts out do transfer, a lot of details, a lot of TLS and SSL data, certificate information, ALPN negotiations, details from the certificate, and it goes on to details. In this case, it negotiated HTTP2. We get to see the HTTP2 headers, even the pseudo headers in HTTP2. And then we can see the actual HTTP requests being sent to the server, and then we can see the server responding, and we can see bytes getting read as they from the server as curl receives them, and blah blah blah. And then here finally we get content from the server. So this is HTML then from this server curl.se. So a lot of things you get to see, and this can of course be very verbose at times. If that is not enough, we have some other fun option here for you, and that's the write out option. It basically helps you output information after a transfer is done. I'm in the way. I wanted to do this. So by providing this option, you also ask for what particular information you want output after the transfer. In my previous example, when I used that -d moo, that was a post. It was a HTTP post with the data moo, 3 bytes. Maybe I wasn't quite clear on that. Anyway, so if you want to have information from a transfer after the transfer is done, you use this -w or -- write out. And in this case, it's a formatted string, so this particular string is not really interesting, but it has variables in this string that you can use to output. There are a lot of variables. You can then read that string, for example, from a file, or you can get it from standard input if you want to. And in that formatted string, there are over 50 different variables, and you can use them like this, for example. If you want to output the content type from the response, or the response code from a server, or whatever, there are, as I said, there are lots of different variables here. So as you can see, the variables are accessed with this percentage and braces around the variable name. And then you just go ahead and output that. And you can output that to a standard out, standard error, and you can also, since very recently at least, output that to a file as well. So basically it provides a lot of data from the transfer for you to output in case you need that, you want that in your scripting or your results or whatever. There's also this feature in here to output particular response header content. So for example, if you want to get this, if you get a response and it says server : Apache 2.4, that's content in the server response header, and there's usually also a date response header, for example. And then here's a write out string that outputs the server header field and the date header field, just in case that's what you wanted. And you should look it up because there are many useful and fun variables here. And by the time I'm sure we will add more variables and more information to this over time, because this is a really handy and convenient way to get information and extract stuff from the previous transfer. When you use multiple URLs with curl, curl always tries to use what we call persistent connections. It means that it will keep connections alive as much as possible. And what does alive mean? It means that it doesn't close them prematurely. It doesn't close them easily, actually. It just tries to keep them alive. So once it has set up a connection, it tries to keep the connection alive, keep the connection there in case you need it again. So if we do repeated transfers that uses the same host name and other conditions, we can reuse the same connection. This is of course a performance boost, quite significant one, because setting up a connection can be quite costly in CPU and time and everything. And if you have the connection already there, it's much faster. So a connection can be reused then if it uses the same scheme, host name and port number, and other conditions too, actually. But I just wanted to emphasize that it's not based on IP address. It's based on host name, not IP address. Because if you then want to use the same name again, we remember, we already have a connection to this name, not the address. Because then you can skip the entire name resolving part. And of course, when curl, the tool, exits, it cannot keep any connections alive. So when curl exits, the connections, they close. That's just how it is, right? And just to sort of drive it in properly, this is how persistent connections work, illustrated. So we invoke curl, right? And we, in this particular example, we use first one URL that downloads from example.com, https example.com/file1, and then we get another URL. It's completely different host name, still HTTPS, and but it's still a different server, right? So it's not the same connection. But then we do another request, another URL to this example.com host again, and then again to the curl.se, but a different protocol. So basically, curl, the laptop here, sets up the connection to the first to the example.com. That's the first URL, right? https:/example.com/file1, and we get that data from that server. And then it says, oh, we're going to talk to curl.se. We set up that connection and we get that transfer. But then the third transfer, you see, same scheme, same host name, same port number. We can reuse the same connection again. So the third transfer here reuses the same connection to example.com, and we gain a lot of speed by that and save resources and everything. But the fourth transfer, it's still the same host name, but it's a different scheme, so it cannot reuse the same connection. So it has to do a separate third connection here to do the fourth transfer. And of course, after all these 4 transfers are completed, now we have 3 connections live. So if we would have added a 5th transfer, it could possibly have used any of these 3 live connections then. And of course, the connection pool has a limit, so it's not going to just keep everything alive for eternity, but it's going to close them off as it goes along as well. So when you do downloads, you, as I mentioned, I had this example before, when you do -O, also called -- remote name, it picks the name from the the rightmost end of the URL, the file name part. That's where it picks the file name. So sort of, when you provide a URL, you can see in the URL which kind of file name it will use, and that's how it saves it. It's kind of convenient. Sometimes there's this content disposition header in the server, which provides a different name. Sometimes the file name part of the URL is really crazy, and sometimes the servers are set up to do this. So you can use this remote header name and say, I want to use the name the server tells me to use, which of course is a bit dangerous because you might not know that ahead of time. So if you save it in a directory, maybe you overwrite some other files that had the same name or something. It's a little bit tricky to use that, but it exists. And of course, you can always use the shell redirect, so you can just get it to standard output and redirect to standard output. Often also very convenient, and in particular then because then you can do a lot of URLs at once to the same output. You can limit, for example, if you only want to do this, make sure that you never do this with files larger than a certain number of bytes. You set the limit, and I never want to do the transfer if it's bigger than this, just to prevent perhaps if something would have grown to some ridiculous size before you do the transfer. But it has a limited functionality and is easily worked around because you don't always know how big a file is ahead of time, and then this option is a little bit useless. So be aware. Some other fun option that often used in combination with the -O is the output dir option. It basically says, the -O saves in your current directory by default. So where you run curl, it will save the file, and that's kind of inconvenient sometimes. Then you can use the --output dir option and says, instead of saving it here in my current directory, save it over there in that other directory. Let me show you. So for example, if I would download, let me see, for example, a typical random file from the internet called curl, like 8.2. What's the version number? We can. Here's a download from a server somewhere, right? Bam. So now it's downloaded, and we know which kind of file name it uses. We know that it is this file name. Oops, sorry. Because that's what we told it with that -O. So we can make sure, was it actually that? Yeah, there's 3 megabytes file there, exactly as we told. But if we didn't want it in the same file, the same directory, we could have used output dir and specified somewhere else, right? And then it would have tried to save it there instead. In this case, I don't have any such directory, so it doesn't work. But if I would do somewhere as a directory, now there's a directory here called somewhere, and I could then put the download in somewhere instead of in my current directory. And we can just check somewhere, and there it is. Easy peasy. There's also this other option that you can also use, which is kind of handy in combination. That's the create dirs option. So that makes it possible to do what I tried to do first here. If you go here and I provide an option that doesn't exist somewhere else, and then I use create dirs, it will then create the directories that I'm asking to use, but they don't exist. And then you see somewhere else. Yep, there it is. Exactly as I asked for, and it created them for me because that's what I asked for. So, downloads, getting things down from the cloud. And sometimes when you download things, you fail. The transfer fails, and then you want curl to automatically retry, because what if you set up a cron job, you want to download currency rates every night, and if the server, for example, has some little glitch at 4 a.m. in the morning when your job runs, you want to tell curl to retry again. If the error is transient, sort of temporary, and the server knows about it and it says so, why not try again? So we have this retry option. Creative name, right? It retries. It's an option, it says retry, and you specify a number. Retry this many times. So in case it's a transient error, retry this many times and then give up. If it still fails, it'll return an error, but otherwise it'll try again. Of course, it has this default delay, I think it's exponential, so it will delay a little bit longer after every failed. But if you want to specify yourself, I only want to retry this for a particular time. Maybe I just want to do this for a minute. So then I can limit the time it will do those retries, because then maybe you know why. I don't know. Or you can set a delay between each retry. So give it a minute between each retry, or maybe you can give it an hour between each retry. You decide. You set the number of seconds to wait in case it ends up in a transient error. You can also actually then tell, well, wait a minute. Let's consider a connection refused as a transient error. It's typically not a transient error, because a connection refused is not typically transient. It could be something else, but you can tell curl to treat it like that, and then it'll consider, oh, it couldn't connect to the server, it got a connection refused, but it will retry anyway because you asked it to. Or you can actually, the big hammer here to retry is to retry on all errors. Whatever happens, retry if you got an error. It might be a little bit blunt, so be careful about this, because it literally means any error, retry. And keep it in mind. Of course, you can upload data. Curl can download and upload. Sometimes we forget about the upload part, right? Because maybe download is a little more used once. Again, remember upload from your client up to the server. And that's very easy. Usually, pretty much whatever protocol you're using, you just use curl-T file name and the URL. It's actually called --upload file if you want to do it with the longer version. And if you don't provide the file name part in the URL itself, curl will put that file, the local file name, at the end of the URL. I'll show you like this. If you want to upload the local file name called file to this URL, as you can see, it ends with a slash. There's no file name part in this URL. Curl will then put that file name part in the URL at the rightmost part of the URL, so it'll be called file in the remote side as well. Or you can decide to put it there yourself. You could, for example, upload it to a different name. And if you want to do it HTTP wise, I'm going to get back to that because we have just gotten started and there's a lot to say about HTTP, but I'm going to save that until we're sort of all warmed up and cozy. So anyway, so if you do transfers, upload, download, sometimes you want to control the speed, the pace, you know, how things are going. And curl then offers a busload of different options. What if you're doing a transfer and it really, you know, it goes really, really slow and let's stop it. If it goes too slow, cancel it, go away. We can try again tomorrow. And how do you tell curl to do that? Well, if it's below a certain threshold for a certain number of time, a certain period of time, then kill the transfer. If you're below, and here we're talking about bytes per second and then second. So if you're below 10,000 bytes per second for 60 seconds, kill it. Or you could, you know, if you're below 10 bytes per second in 5 seconds, kill it. Or why not do it like this? The reverse situation, pretty much, right? You don't want to clog up your pipe by my huge download that just eats all your bandwidth. So no. Just use approximately 100k per second. This is kilobytes per second when you download. So don't download faster or don't transfer faster than this. Basically, it could be, if you want to, for example, if you want to do a huge number of simultaneous curl command lines, right? And you know you have a limited bandwidth, maybe you want to make them, you know, work together in a better way. So maybe, I don't know. If you want to limit the rate, if you want to slow it down, make sure that it doesn't go faster than this. And by this, it's actually a rough average. So it might actually during periods be slightly faster, slightly slower, because going with the limit rate like this, it's a bit of a black magic thing. So don't get upset if you get 101 or 99k instead of 100, but it'll usually average out on 100. So, and sometimes you might, let's not do more than this number of transfers per time unit. And this, for example, might be the case when you get a lot of transfers with curl, but you don't want them, you know, you don't want to torture your server by getting 1 million transfers the first second. Maybe you want to distribute them over an hour, a week, I don't know. And then you can tell curl, no, use this rate of transfer starts, not more than 2 per second. For example, here's a range, download 20 JPEGs from the server, only 2 per second, or rather not more than 2 per second, or not more than 3 per hour, or why not more than 14 per minute? And then there's, as you can see, SHM. There are, look it up in the documentation, it's all documented. So this number of starts per time unit, to make sure that you don't, you know, kill your server by going overly eager to get your stuff. You can also do other fun things. For example, if you, in many cases, for example, if you want to deploy your site, you're gonna deploy your site, and you know the name of your public site, and it's up there, but you're working on your private development version of this server, and it's over here with different IP address, but you want it to use, then you can go with, for example, redirect. You use the correct URL, but you can sort of fiddle with the name resolving. For example, like this. So instead of going to the resolvingexample.com and going to the realexample.com site, you tell curl that example.com is actually resolved to this IP address, 127.0.0.1. So instead of going to the realexample.com, it will go to your local host and try to get this page, the URL. Of course, if you're using FTPS, there might be some challenges. But anyway, you can do it like this. Or you can redirect to an IPv6 address, of course. Or you can even, there's a different thing, you can even redirect from one name and port number to another name and port number by using the slightly different option called connect to, which is which I know people have been using. For example, if you want to go to, let's say you have a particular site and your site consists of 12 different load balancers. So you go to either one of those 12 when you go to your site. But today you want to go to a specific one that you want to try. And so then you can, instead of going to example.com being the generic one, replace the example.com with your particular specific load balancer host name, and use that instead. Or whatever. You can pretty much, these are very much, it allows you to fiddle and be creative with how you want to do things. So, and in particular, when you should remember that what is in the URL, that's for example, where curl picks the name for the SNI when doing TLS negotiations. So it's you want to make sure that you understand that. So when you use the right name in the SNI part, that's what decides which certificate the server will provide for you. And that's also, the server will also make sure that the SNI name is a name that it knows about, so that it knows that you're talking to the right server, the right host. And of course, if you're just basic HTTP lingo, it's sometimes fun, useful, convenient to be able to set the host header, and then you can just set that host header. It's just --8, set the host header to something that is not the same as a server name, maybe, or maybe it is. It's up to you. Again, if you use TLS, and you really should, then you might have certificate checks that fail here. So sometimes that might actually warrant that you're using --insecure or -k if you're perfectly aware of what you're doing and you don't do it in production. I don't know, you decide. Anyway, so when we set up connections to different servers, I showed you how it reuses persistent connections, and I also wanted to get into how do you set up a connection these days, and maybe you're not really aware how we do things in modern TCP clients these days. And we're starting out simple. We raise IPv6 versus IPv4, and we call that happy eyeballs. It's an algorithm. It's actually what is said to be the correct way to connect to servers using multiple IP families, or IPv6 and IPv4. You can avoid this by saying, I want to use IPv4, I want to use IPv6. If you have a particular reason to restrict yourself or curl to that, you can do that. Look at that, that's a curl on a laptop. And curl, of course, it wants to connect curl.se in this case. It will resolve the host name from the DNS server, right? Hello, DNS server, where is curl.se? And curl.se is actually an excellent example here, because curl.se has a ridiculous amount of IP addresses. So look, 8 IPv6 addresses and 4 IPv4 addresses. So how do you go about to use them? Well, first curl will use all the IPv6 addresses, initiate the connection, and it will iterate through them all. Try the first, then if that fails, try the next, try the next, try the next, try the next, and the first one that works, it'll be happy with, right? But if once it has started this IPv6 connection attempt, it will slightly afterwards start with its IPv4 attempt. So they will go in parallel at the same time, and the one that is succeeds first, it wins. So in this case, it gives IPv6 a little head start to make it sort of prioritized a little bit. But if it's slow for some reason or fails for some reason, IPv4 might win. And both of them have this, each of them have their own lists with IP addresses to go through, right? So if one of those fails, it'll try the next one until it's run out of the options. And the first one that connects, it wins. Everything else is cancelled, killed, disconnected. And that is the connection that curl will use. So connections then, they use a specific network interface. So you can also actually, if you have multiple network interfaces, which you might do in servers, you can actually ask curl to use this particular network interface when you go out to reach to that server. This is really a particular choice, but usually you don't care. Usually the routing table in your kernel will do that for you. You can also do other things that usually you don't care about, but you can limit the port number range that curl will use as source port numbers in the TCP connection. Also, again, you have to be a particular condition to do this at all. There's also this, for example, when you do TCP connections, as all of these are mostly often, at least using TCP, you can set a TCP keep alive. TCP keep alive is a little option that you set for a connection that makes it send a few bits and pieces back and forth every now and then to help curl to detect when the connection goes down. And you can use that. You can set keep alive time, send a little ping every 23 seconds, even if nothing happens, to just detect disconnects better. It actually sets TCP keep alive by default, but this allows you to set the timing if you want to do it more strict, for example. And why not use your own custom DNS server? And this, of course, if you build curl with cAres, which I'm afraid to say most people don't. But if you do, you have the option to say, I want to use that particular DNS server when I resolve the hostname, and not the one that I would otherwise use. Which is also a way to be creative and for particular use cases. And of course, doing things over the internet sometimes is very slow, sometimes it's ridiculously fast. Curl doesn't really know how fast things are going to be. Maybe you're very, very close and you have a really high-speed network. Maybe you're talking to a server on the other side of the globe and everything is really, really slow. So then we provide options to say, I don't want the entire operation to take longer than this many seconds. My transfer from the moment I start it until it's done, it should not take, it's not allowed to take longer than this amount of time. And in this case, 12.34 seconds. This is number of seconds. So it limits the entire operation. It should be done within this, or it will be stopped and an error will be returned. This, of course, it's really hard sometimes to set this maximum time because, again, maybe you don't know either how fast it'll be because it's really hard to know. So it's usually you don't want to have this too restricted because maybe it's very slow sometimes and very fast other times. So you can also instead say, wait a minute, I just wanted to try to connect to this server for this amount of time, and if it hasn't connected by this time, fail. And this allows you to just maybe fail earlier, because if it takes this long just to connect to the server, it's maybe not even bother, it may be not worth to try it. So only try 3.14 seconds in this case, and then give it up. And I want to say then, because I get this question sometimes, the connect timeout is sort of the time from start until the connection is there and connected, everything up to that point, and then it's not counted anymore. So if you set the max time to 12, that's going to be everything is going to be done by 12 seconds. If you set max connect timeout, if you set the connect timeout to 3 and the connection connects, then there's no more timeout. So you usually, sometimes at least, often use both of these options so that you can limit both the connect time and the maximum time, or either or, you choose. So I mentioned this briefly before. This is a way to provide credentials. This is a .NET RC. It's actually a file to store credentials. It's actually for FTP servers, and it was invented a long time ago. The default one is in the home directory called .NET RC. It's actually invented or created back in 1978. So it's not quite as old as I am, but it's way, way, way older than curl. And if you use .NET RC, curl will find that and use it, and use that to find credentials for your particular servers that you're using. You can also actually, like this, identify a different file if you want to use a different file. Again, if you save credentials in this file, you really want to make sure that nobody else can read this file, because you don't want your secrets out. Well, maybe you do, but you should do that with knowledge at least. And it works for all protocols for curl, and it's actually a very weakly specified. I call it a standard. I don't know. It's not a standard. It's more of a habit or a lot of implementations use it, but there are different interpretations how to parse everything, so it might not work perfectly interoperably between tools. Anyway, this is how it looks like. If you check, this is credentials logging in when you access the machine example.com. Machine, login, password. Easy peasy. And of course, when you run curl, one of the convenient things you want to do is, especially when you run curl from shell scripts, is that you want to check the exit code, right? Because the exit code will tell you how it did. If it returns 0, if it exits with an exit status 0, that means success. It succeeded, no error. It went exactly as what you asked for. You got what you asked for. So if it doesn't return a 0, something went wrong. And then it returns a numerical value back then, so to the shell prompt, whatever called curl. And it's very convenient, and it's 0 for success. 0 means everything went exactly what you got what you asked for. Everything else is an error. And what particular error, the number actually tells you, because the number is there. It's a fixed static error number that will tell you exactly what it is. And you should, of course, test for that pretty much. If you do like this, for example, if you cannot save this file in this particular directory, you get an error, in this case error 23, failure writing output to destination. Yep, you can't save it there, error 23, so it failed. And then you can check in your man page, what does error 23 mean? If in this case, of course, it actually says it. So anyway, you can also then, of course, if you write a shell script, for example, write the curl command, check the return code. Was it 0? If it wasn't 0, it failed, and then you can, well, take action. Or rather, when you write shell scripts, you probably should do it like this, or some version of that. And there are, I think we have documented up to number 99, I think. And they're all documented. This is a snippet from the man page, the first 12 error codes. I'm not going to read them. I'm just going to show you that they are there. So they sort of describe what they are, and they are fixed. They will not be changed. When we add new ones, we add them last. So the ones that exist now, you know that error 7 there, you see, failed to connect to host. Yeah, it's going to be number 7, even 5 years down the road, or 12. You can do curl to a lot of protocols, of course. I just want to highlight a few of them, a little bit particular, because SCP and SFTP is a little bit different than many other protocols. They're based on TLS, so they're not based on TLS. They're based on SSH, which makes them a little bit different because they don't use the CA system, for example, and that's not a little bit different. So anyway, you use it just like any other URL, and in this case, you're telling curl which username it should use. You can use SCP. They're two different. They are different protocols. They both go over SSH. So, in particular, we usually recommend going with SFTP, the first one, because it's slightly more portable and defined. The second one, SCP, is less portable, but use whatever works for you. If you terminate or end the URL with a trailing slash like that, it's marked in blue here in my example, you will get a directory listing because there's no file name part there. So you're asked for a download, but without a file name in the URL, it means a directory listing. And that goes actually for several of the protocols curl supports, if they support directory listings. That's SFTP, FTP, and a few others. A little peculiar thing with the SFTP URL format is that if you go with just, if you can see this /tilde/ thing in the beginning of the path, it actually means that it gets this file to-do.txt from the user's home directory, based on the particular user that accesses this site. It's a little bit extra thing, but both SCP and SFTP do that. And of course, these protocols, they use this .ssh/known hosts file by default, which is a host. It's a file that basically remembers fingerprints from the servers you have accessed in the past so that it'll detect if the servers change or if they're the same. You can also use this -- insecure, similar to how you would do it with the TLS-based protocol. It basically means skip the known hosts check, so that even if the server name and the fingerprints deviate, if they don't match, ignore that and continue anyway, which is certainly an insecure way to do it. And you really should avoid insecure, of course. You can also read email, and by reading, then of course it's a downloading curls lingo, right? And yeah, you can absolutely upload with SCP and SFTP as well. Yeah, most protocols I'm talking about, you can actually do both download and upload. IMAP you can upload to. POP3 cannot upload; it can only download. But from a curl perspective, reading an email is like getting data. That is a download. So if you want to read a POP3 email, you can do that with curl. On an IMAP, there's actually a little more complication than just what I'm showing you here, but sort of the gist is like this. And of course, you want to add TLS, as I've already mentioned several times by now. But so that and in the same vein, you send the email by uploading data to SMTP. SMTP then cannot download actually. And in the same as before, I showed you before how to do an upload with curl. You use --T, send data. This file has data. You send it to this URL, and here are the credentials with the -u option. In the SMTP case, you need to have that file formatted correctly and so on. So it's a little bit complicated because, as I told you a little bit before, curl doesn't actually know about content, right? So it doesn't know how to make a mail content like that. But it knows how to send the actual mail. It's a little bit complicated, but you can easily learn it. And going on further, you can do pretty much the same thing with MQTT. It's usually a way to work with smaller embedded systems, and you can download data. That's basically means subscribing to something like a bedroom temperature, or you can upload data or set data. That's sort of you can set like this. You set the value of 75 to the kitchen dimmer with the MQTT : / scheme in URL. So download, upload, even though in those particular protocols they don't actually speak about download, upload. Going further, the same thing again. TFTP, another protocol, usually working with. There's an older protocol done over UDP. People usually has been for embedded system, typically booting, when download your bootloader or something over the network when you want to start the tiny little system, and then because the T stands for trivial, so trivial file transfer protocol. It's pretty easy, basic thing, but it works the same thing. I mean the same way. As you can see, the command line. You want to download something from the TFTP server, just specify it, or you want to upload a file to the TFTP server. Again, --T. There's the file, there's the server, there's the URL. Upload, download. You see a pattern here, I hope. Telnet, of course, is the odd child in the family, and really, if I would have done it today, maybe I wouldn't have allowed Telnet in, because it's not really, it's a weird sibling. But you can use it, and you can connect to it, and it reads input from standard in, it will send output to standard out, and it's really inconvenient. It doesn't really do uploads or uploads. It's that session-based thing. So you can use it and play with it. It's fun, but it's different. Let me say that. Another fun thing, of course, maybe not the mostly used protocol in the curl family, DICT, dictionary lookups. And here we can see some examples. Let me see if I can do one of them in a terminal instead, like this, curl dict, and this is then a dictionary lookup of the word curl on this on the server dict.org, which is then a dictionary online. So then I ask for it, and I get different matches for curl like this. Very, very useful. Yeah, there are. I can obviously then use, like, if I use a definition of Heisenbug from the dictionary jargon, I think that's what it means. And then I get the definition then like this. Very fun. Or maybe not. Okay, so at least there's also this experimental protocol support for WebSocket. It's coming. It's still experimental, so it's not enabled by default. So most of you will not have it. So I'm not going to get into much of the details here, but it's going to be used in a similar way. WebSocket is not strictly upload-download either. It's more of a session thing, but it's used as an upload-download thing often enough so that in many cases you can point this to a WebSocket stream and you just get it sent out somewhere. Anyway, by the time in the future you will be able to try out much more about with the WebSocket stuff at least. So I wanted to mention then that a lot of people that are going to use curl and use curl to mimic things that the browser do, or to do things with the browser, and they try to do things with the curl command line. And sometimes you end up, wait a minute, what it looks very different. I did it with my browser, and then when I do it with curl, it looks completely different. Why is that? And can you explain that? Sometimes phrased in less friendly way, but it's of course one of the primary reasons why. For example, when you get things sent to standard, let me move me up there. If you, for example, use curl and you send data to standard output in your terminal, for example, and you get a particular HTML file, maybe the character set that you're downloading is not the same one you're displaying in your terminal. So character set is a big explanation to why the HTML on a browser would show something in a completely different way than you would see when you get the raw HTML in your terminal. Or even if you load it into your editor or whatever, it might not be the same character set. That's a very big explanation, and you might have to ask for the right language, character set, or whatever in request headers. And many times the server will also give you different results depending on who they think is asking. And who they think is asking might be following protocol standards and just follow, proper headers, or they might be second guessing who's there and just give you depending on who they think or who they guess is actually asking. So there's actually always a risk or sort of an opportunity to get different things from depending on curl and browsers. And then of course browsers and the web today uses a lot of JavaScript, and curl doesn't do JavaScript. So if you download something that has JavaScript in it, all bets are off, and things are going to go completely different ways in the browser compared to the curl request getting the same URL. Just remember that. And of course, then when they do things with JavaScript and everything, they can also set cookies, for example, in JavaScript. And if curl doesn't do JavaScript, the browser version might get a lot of cookies and so on. I'll get back into more HTTP details soon. And of course, nowadays, let me save that. I want to show you then. So, for example, if you want to figure out exactly what a browser does, and you want to do that with curl, you can of course figure that out yourself, or you can use the feature copy as curl. It is a widely it's a common feature these days in a lot of tools, and in I think all the browsers nowadays. It basically is a way for you to generate the curl command line to mimic a previous transfer. All of these browsers, all the big ones, have the copy as curl feature, and it's actually available in several other tools as well. I know it's available in several sort of man-in-the-middle proxies and other tools that help you do things HTTP. You always have to remember that this is never perfect. It's always as a starting point. It might be it gives you a good insight exactly what to do, but then you need to do something fun yourself with it. And I want to show you a cool little example here. And to do this, so I'm going to take away the terminal and I'm going to bring up a Chrome browser. So this is a Chrome. It shows a website I've seen before, and I'm going to show you. I'm just going to find it here myself. So here's the. I'm scrolling here. Here, if I press F5, it'll reload it, right? It was very slow for some reason. It doesn't matter. So anyway, so here's the web page, and I can press F12 to go into developer tools. F12. There's also a menu option, but I don't want to press the menu option. So if I go here and I press the network tab here, and I can do the reload again, and then I can see that we have a lot of, well, maybe not a lot, or some web pages will have a lot more resources. But we can see, for example, this. The browser got the main page, the HTML page, and then we can go, I want to do this with curl. Copy as curl. Select. Nice. Where is my terminal? Here it is. Remove the browser, and then in my terminal, I don't want to see any more dict. I paste the curl command line. So this is the curl command line Chrome say they used to do that. This is done pretty much the same thing Chrome did, but in curl lingo. I press and I got nothing. Yeah, to show you how complicated things can be. And of course, if I wanted to figure out exactly what happened, I would use -v. Oh, right, and you see, we got it 304. It means that it has not been updated since the one we asked for, and that means that this particular request used conditions like this, blah blah blah. So it actually didn't get a new one because we asked for not getting it if it's not been modified since this date. I'll show you in a second how that works. And I also, if I do remove my terminal and I pop up a Firefox instead, looks very similar, right? So if I go to the Firefox one, it's here, and if I, for some reason, it's the same key, right? F12, and here's a network tab. I can do reload, and again, look at this. Here's the front page, and I can do copy value, copy as curl, select. I remove the Firefox, I bring up my terminal, and here's the Chrome thing, and now instead I paste the Firefox one. It looks a little bit different, a big blob of stuff. Does it use the conditional thing? At least, yeah, it does, if modified since. So yeah, it didn't get anything either. So it also got the 304 response, and if I add the -v, I will see the HTTP2 304 not updated. So, fun thing. That's a very convenient thing. Oh, yeah. So that's a very convenient thing. I can recommend using that when you want to reproduce what a browser did in curl. It's never perfect, and you should be aware that cookies, and for example, you want to double check exactly what it's doing and how you really want to do it. And you can do other things to figure out the browsers. I will show you later on how you can do SSL keylog file, and also this other fun thing. If you want to mimic, for example, I wanted to show you this fun little service that I have, which is called calls headers to curl. So basically, if you do like this, and now I need a terminal as well. Here's my terminal. Okay, so if I go to now I have different tabs on this terminal. So as you can see, they change color. So in this tab, I'm going to run NC being network cat or whatever it's called. So the exact options here vary a little bit. There are different versions of NCs. So sometimes it's not -L-P, sometimes it's slightly different. It basically means wait for listen for a connection on port 8080 and just output what it does. So it does nothing right now. Port 8080, and then I could go, like, I can switch on my Firefox over here, and I can go to localhost :8080, It didn't do anything, we think, but if we check out the terminal in the back there, we see that it actually, my mouse is acting up a little bit. So where are we? Hello? Okay, sorry for that. Okay, so there we can see in the terminal that we got a bunch of headers, right? So these are these are that's a fun cookie. I don't remember. That's some kind of test cookie I've done for. Anyway, so we can see that these are the this is the request that the browser would send to the server. So why do we do this? Well, it's a cool experiment, right? So this is what the server did, and we can copy the entire header set, right? And we do copy. That's how I do it with this terminal. And we can go back to Firefox, and then we go to my cool service called headers to curl. And in this particular form here, we just paste the entire header set, the entire request actually, from the get down to the last header. Bam. How do we make a curl command line that does the same thing? Convert. Bam. And here, this is now the curl command line that reproduces the same browser request that we just did towards our own server. So that's a completely different way to mimic the same thing, but sort of listening in the server end rather than copying it from the browser. It's really convenient, and this is also convenient in particular if you have the headers somewhere, or like there's a big bunch of headers and you want to convert them to curl command line. Just a convenient thing. And of course, I can never talk about curl without mentioning the cool --curl command line, which is of course a way to generate libcurl source code from a curl command line. So if you do curl command line and you're happy with it and you want to convert it into a libcurl source code, --libcurl is there for you. So you want to go yeah, for example, if we go back, where am I? I'm in the wrong tab. If I go back to one of these huge generated things, right? This is the one that Firefox generated as copy as curl from Firefox. Okay, but we want to make a libcurl command, libcurl source code that uses this. So I add here on the very end of the command line. I could put it anywhere in the command line, but I put it in the end. I do cool code.c, and then when it does this, it now saves a C code. It's now called cool code.c, and this is now an embryo for how to write. This is now, if I could now compile this actually, and I will have the first embryo to a command tool that actually performs this request then that we just copied this way. As you can see, it doesn't make a perfect copy of everything, so you might need to tweak it, and there are some defaults and so on. So, but this is meant as a first skeleton and embryo for you to get something started, and then you build from that, and what could possibly go wrong? It's pretty cool, and is actually also that way that even if you don't use C, even if you want to use another one of these bindings, there are over 60 different bindings for libcurl. So even if you want to do a different language than C, doing this way, you at least get a lot of options, names, and a rough idea how to do things, because most bindings are very thin layers on top of the C API. So then you can usually pretty easy copy it over and modify it just a little bit. Going forward into TLS. I'm only on slide 81, and I'm 2 hours in. So if you thought I was going to do this in 2.5 hours, I'm sorry to do at this point. Might be done in 3 hours. Okay, so again, you want to do TLS. You don't want to do the protocols without TLS, also referred to as SSL all over. In our documentation, we mix and match SSL and TLS all over, all the time. It's the same thing, or actually nothing is SSL these days. It's all TLS, but the name is still used all over. So don't care about if it's SSL or TLS. It's the same thing to us. It's done for transport security. We want it unless we use SSH. Of course, SSH is also fine, but their SSH is only for SCP and SFTP. For all the others we talk about, we use TLS. And when we talk about TLS, we protocol-wise actually verify the peer. And what does it mean to verify the peer? It means that we have a handshake, and we verify that the server we are talking to has proven itself to have a certificate that is signed by someone you trust, and so on. So there's a lot of digital checks there, right? And by doing that, we prevent eavesdropping. No one on the network, off the network, no one in between can read your network, your data, or anything. And they cannot tamper with the data. They cannot change anything. So they cannot see what it is. They cannot modify the data. And typically, the use of TLS is sort of indicated or hinted by the URL scheme, as in HTTPS, S therefore secure. So we know that if it's HTTPS, it has TLS. But of course, you can still kill security by by doing it wrong. Don't do that. And all schemes cURL supports then, so that ends with S, they do TLS. So basically, IMAP S, SMTP-S, POP3S, they're all TLS based. And if you want to do TLS with one of these other, some other protocols, and which protocols they are, you can only sort of learn by reading the documentation. But FTP, IMAP, POP3, SMTP, LDAP, they all have a different way to upgrade into TLS. So they start out without, they can start out without TLS and then negotiate your way up to TLS based. So you can go with an FTP : //URL, use SSL required option, and then it'll sort of switch over to the TLS version, which is also the fine way to do it. And again, use TLS. With TLS, there are different versions. We started out, well, SSL was created in the mid-90s by Netscape. SSL v2, I think, was the first one that was ever used. It was later deprecated because it was insecure. Then we got SSL v3, also deprecated because insecure. Then we got TLS version 1.0, and also deprecated by now, and so on. So we have sort of gone over a range of different versions over the years. But you should know that cURL always tries to get the latest and most suitable sort of set of version and ciphers negotiated automatically. So typically you don't need to care about that, but you can. If you, for example, if for some reason want to fiddle with that, you can ask for a lowest possible accepted version, and you can ask for a highest possible accepted version of TLS versions. Usually you don't want to care. We also have the SSL v2, SSL v3 options. They typically never work these days because the TLS libraries and all of them have disabled them, so don't bother. When cURL connects to a TLS server, it verifies the certificate in the server side, right? Connects to example.com, check that the certificate we get from that server is trusted. It comes from example.com and it's been signed by someone we trust, by a certificate authority. And cURL is set to trust a number of certificate authorities that have then been used to sign certificates to servers all over the world, right? And those certificate authorities are basically a bunch of signatures in a file somewhere in your file system. There's also let's don't care about that. So you can then typically use cURL as the CAs in a file somewhere in your file system, or you use the native way to check certificates. The native one is, for example, if you use S-channel on Windows or you use secure transport on Mac, they have their native CA support. So basically cURL just asks the operating system, is this trusted, and then they tell you. Otherwise you can use this option --CA cert to point to a file. These are my CA certs that we should trust, and you can edit that and only provide the CAs that you trust. You can avoid checking the CA the certs completely the server cert by using the insecure or -k, which then of course, as the name implies, makes it really insecure because you skip the check. You don't know that you're actually talking to the right server. And if you don't talk to the right server, it could be an imposter, and then they, of course, the fake one could read all your data and give you the wrong data back or whatever. Everything is then open for bad stuff. You can use, and here's a URL to a service we provide that always provide the Firefox CA Cert bundle automatically converted for you in PEM format, so it's actually updated daily. So if you go there, you can get the latest CA Cert bundle that Mozilla maintains, provided for Firefox, and you get it in a convenient format that works immediately for curl in a PEM format. And avoid -k, which is then of course the insecure thing. With curl you can also check for stapling, because certificate revocation, you know, when a certificate has gone bad and you want to revoke it, the system for that doesn't really work really well over the world. So sometimes bad certificates remain out there and remain in use, and it's hard to detect that. And one way to sort of counter that bad system is to use OSCP stapling, which basically means that the certificate provides a guarantee that this has been recently verified to be up to date, and you can use curl to ask for that stapling check, that your double check that the server is actually still, it's not revoked. You can also do the certificates the other way, which is basically the client providing certificates to the server saying, hey, I'm the correct client talking to you. Often called then the mutual authentication, because server to client always happens. So if you go with client to server, also it's mutual. And then you pretty much just, here's my certificate, here's my password, or split up in different options. Here's my certificate and my key when talking to a particular server. And how would you get a certificate? You would get it somehow from the server or from some admin somehow. I don't know how. Usually using some other means, using a secret handshake in the park yesterday evening or something. And of course, you can, when we're talking TLS, there are TLS ciphers, different ways to encrypt and hash things. So you negotiate which ciphers and everything to use, and the client of curl of course negotiates that with the server when it sets up the connection, and which particular ones to use you can control or change with the -- ciphers option. Again, typically you don't do that, because typically you just use, and curl does its best to pick the best one, but you can change if you want to. And if you use a TLS based proxy like an FTPS proxy, there are different options to set the proxy option, so you can go with both. You can control both the connection to the proxy and the connection to the remote host. So lots of stuff. When talking about ciphers today and TLS, people then often bring up post-quantum, because that sort of lies in the time. So post-quantum, when the quantum computers come, they will break a lot of ciphers and rather encryption algorithms that we've been using in the past. So if you want your data that you encrypt today to survive when the post-quantum computers sort of become capable enough, you need to switch to post-quantum safe ciphers, right? And how do you do that? Luckily for us, that's all in the TLS library. So if the TLS libraries support post-quantum ciphers, you can select them with the same options. Sort of out of our hands, and we pass on that responsibility and fun job to the TLS libraries. There's this URL with lots of SSL cipher names if you want to read up more. I should also just mention then that of course curl supports a lot of different TLS backends. So if you run your particular curl command line today, depending on things, one of these different libraries on the right side might have been used when it was built, and you might then have different behavior. They might use different CA stores. They have different features, and they work on different platforms. Some of them are native on platforms and so on. And OpenSSL is the by far most commonly used and sort of possibly the most commonly known as well. And that is one of these 12 different ones that curl can be built to use. And of course, if you build curl yourself, go crazy, go with the one you want to use. Slightly limited, of course, depending on which platform you're on. So it might limit your options. In TLS, we encrypt everything. So when you use a TLS connection from a client to a server, you cannot read the contents of the traffic, right? You cannot snoop on the traffic. But not being able to snoop on the traffic can be really problematic when you want to understand what is going on here. What is happening? I want to know. Nope, it's encrypted. But then luckily someone invented this fun SSL keylog file. Actually, I think it's invented by the NSS people and the Firefox developers many moons ago. So basically what this means is that you can set a environment variable called SSL keylog file, and you specify a file name actually. Set SSL keylog file equals a file name. And then if you set that first, and then you use a tool that supports this, like Firefox, Chrome, curl, when they are started and this one exists, they will save the secrets, the TLS secrets, in that file name, the runtime secrets. So you don't have to figure that out. You don't have to be a sort of, crack it in a way. It'll save the secrets for you. And if you then use a tool like Wireshark, for example, and who doesn't use Wireshark, right? So if you use Wireshark, you can tell Wireshark, get the secrets from this file that we're saving all the secrets to. And then we can run curl, save the secrets, and Wireshark can get the secrets and decrypt the TLS over the wire, or decrypt the Firefox traffic. And it works like this. Here's the config window from a Wireshark a while ago. It might not look exactly like this. And this is on Linux. Maybe it looks different on Windows. So here I said, my pre-master secret log file name is called home Daniel TMP TLS key. The secrets will end up there. So, and then I go there, go to the secret TLS data with my browser, and then in Wireshark I snooped on the traffic, and it can decrypt everything and show contents of, in this case, actually an HTTP2 traffic from way ago. I found this screenshot. It's very old, but it looks like this anyway. And it managed to decrypt the data and show the contents of the traffic. Very convenient. You should use it. Proxies is a way to do traffic sort of with an intermediary that sits between you and where you want to go. A proxy is an intermediary, a man in the middle, somewhere in between. And it basically, if I wanted to show you with the pictures, that's a curl laptop again, talking to the website. And normally we just go directly to the website, setting up a connection, and we communicate back and forth. But when we introduce a proxy in this game, that's the middleman, right? The intermediary. So it sits on the network A. So we do a connection to the proxy first, and the proxy then relays data over to the website on network B. So the client on the left side, it doesn't have a direct connection to the website. It goes via the intermediary. That's what a proxy is, right? A middleman. So it is a common thing in enterprises and companies and organizations to have these sort of mandatory things. So for example, maybe your machine at work, you cannot connect to the server directly. You have to configure a proxy to reach the server. And how do you know which proxy your machine is using? Well, normally curl doesn't auto detect it. It can't find it by itself. You have to tell curl where is it. And usually you can find out that in your browser network settings or your computer's network settings, and there it is. And then you can, for example, sometimes you also have it set in environment variables. That's a common Unixy way to do it. Sometimes when you configure a proxy, especially when you configure browsers, you have these PAC files, proxy auto configuration. A PAC file is something as ugly as a small, well, it's supposed to be small, sometimes it's really big, JavaScript thing that, given a URL, returns what proxy to use, which makes it really complicated for curl because curl doesn't speak JavaScript. So maybe you need to parse that JavaScript. Usually it's very simple. Usually you don't have a lot of different proxies to select from anyway. But you should be aware. Sometimes you need to sort of do a little bit of detective work to figure out which exact proxy your curl command line should use. Talking about proxies, then I also wanted to mention the thing called captive portals. Typically your airport or hotel or stuff when you cannot get on to the internet before you log in, before you pay, before you do something, before you agree to click, that's a captive portal. It limits you until you've done something, and then you're allowed out to the internet. They're not actually proxies, but they sort of work similar to that. And of course curl will always also be, well, not always, but it will be limited by captive portals in the same way as your typical browser will. Doing proxies, that man-in-the-middle machine. There are several different proxy types, and curl speaks a lot of them. So you can have, for example, HTTP or SOCKS, different kinds of proxies. And when you talk about HTTP, there can be different. You can speak HTTP, HTTPS. You can do HTTP2 over HTTPS. And SOCKS also have, we talk SOCKS in 4 different flavors. We have SOCKS 4 and we have SOCKS 5. We have SOCKS 4 that resolves the host name itself, or you let this proxy resolve the host name, and the same thing with 5. So a lot of different sort of flavors here, and you typically set the type as a sort of made up URL scheme when you use the -- proxy option. It's kind of convenient. You can even actually set a pre-proxy that allows you to set a SOCKS proxy that connects to an HTTP proxy. It's super crazy, but some people do that. If you want to do Tor transfers with curl, that is typically set up through a SOCKS proxy. Usually then you do your connection, or you point out the SOCKS proxy, and that is your entry point into the Tor network. And then you provide a URL, and that URL then is used sort of into the Tor network. There's also these concepts of a forward proxy and a reverse proxy. And in these cases, we talk about forward proxy because the forward proxy is usually in the curl, in the client side, curl side. The reverse proxy is usually in the server side. So we can, as a client, as a curl user, we can often ignore the concept of reverse proxies. I'm just mentioning it so that you know that the words, they're there. Curl then of course speaks HTTPS proxies, and if you're going with an HTTP proxy or an HTTPS proxy, again we say TLS is better than not TLS. So go with a HTTPS proxy if you can. So then it'll authenticate the proxy, and it will encrypt all the traffic so that other users on network A cannot see your traffic. If you go with even if you talk to the website with HTTP, for example, which is a clear text version, if you use an HTTPS proxy, you're protecting your network, your data, at least from people on the network A here in this. And of course, curl supports both HTTP1 and HTTP2 when talking to the HTTPS proxy. Complicated but fun stuff, and a lot of options to allow you to tweak those things. Some people are also using these man-in-the-middle proxies that sometimes you use them for debugging, sometimes you use them for surveillance, which basically they try to intercept your traffic without you knowing it. So you don't explicitly tell which proxy to use. They just magically know that there's an outgoing connection going on, so they intercept it and let it go through a proxy, and so that they terminate the traffic and send back something. But the good part with you using TLS all the time is that you will notice, because they cannot do that without sort of permission, because the only way to make that work is that the client needs to permit it by saying that CA that sits in the proxy is okay, it's trusted. Normally it's not going to be trusted, so normally those connections are going to fail. But of course, blindly trusting a middleman like this, and middlemen in general like this, is not very nice. And of course, you can do authentication with proxies, which basically means that you have credentials, and there are different ways to authenticate with proxies, different methods, different algorithms, and so on. We have a lot of different options. Depending on which kind of algorithm your proxy uses, use the one that makes it go through. Typically, you control which proxy to use. You can control by setting environment variables. Basically, they control the scheme in the URL you're using. So basically, if you're going to HTTP : then curl will check the HTTP _ proxy environment variable. So like this, going to the HTTPS, it checks the HTTPS _ proxy. The FTP checks the FTP _ proxy. The HTTP _ proxy. And as you can see, the HTTP one in lowercase, preferably, for reasons. If none of them exists, there's also a fallback and check. Maybe there's an all proxy set, and then it can use that. And it also checks the no proxy, even if one of the above matched. If no proxy contains a list of exceptions, we should not use proxy for these host name patterns. I should also just let's not go into this a lot, but there's also this difference. If you're talking HTTP through an HTTP proxy, you can there's a double sort of request, right? You set up a request first to the proxy. If you do HTTPS through to the website, you set up first a connect request to the proxy and then a remote request through to the website. That means that you're sending headers to two different parties that are involved in the same transfer, and you can separate headers. So curl can send headers just to the proxy or just to the website, and you separate them or you differentiate between them using these proxy header or versus header. Just think about that if you're setting headers when you're using HTTP proxies. Okay, this is going well. We're only 50 slides left. And now, of course, HTTP is one of those protocols that is, well, as we ask users every year, which protocols are you using with curl? People say HTTP and HTTPS. I mean, 99% of all users use these protocols, and then the other protocols are much less used. So these HTTPS and HTTP are by far the most popular and most frequently used protocols that curl supports, and of course, then in some ways the most important ones to curl and to curl users. So some basics just about HTTP. There are different versions. Put it simply, they're 1, 2, 3. And HTTPS, that's HTTP and TLS, right? It's the same sort of underlying protocol. It's just HTTP secured with TLS. So basically, sometimes we then sort of use the words interchangeably a little bit, possibly a bit sloppy at sometimes. And then so basically it means there's a name resolve and you set up the TCP connection and then add TLS handshake on that. Or when you use HTTP3, you actually replace TCP and TLS with quick. It doesn't really matter. And then the protocol is a request response. So you ask for something, you get it back in just one ask, one response. And all requests that we send to servers, they have methods called verbs sometimes. Get, post, head, put, delete. Short words often spelled in uppercase. And this is how a very basic HTTP 1.1 request looks like. This is a get /index.html. That's the resource it wants to get. Then the version of HTTP, and then a set of headers. This just name : value set. Some of them needs to be there pretty much. Host pretty much needs to be there in the request. The other ones are often, I mean, optional. Sometimes you want them there for features and so on. Here's the user agent header. It basically says which client is asking for this. This is curl 2000, very fancy user agent. You can then the same thing but with a different method, different verb called head. This is then, it looks identical, but it's the different method. Or you can send the data to the server by sending a post in this case. And then the data then follows the headers. And as you can see here, the last header here says content length. That's actually the content of the data that follows. So hello, that's 5 bytes, content length 5. Or a variation of uploading is put. Put is actually more replacing the resource. Post is posting data to that resource. Semantic difference, but still there. So it's same thing there. It sends data in the request, 5 bytes. It says hello. That's basically, and this is how HTTP 1.1 looks like. I'll get back to slightly about different versions. Yeah, and here's a response. The first 4 there are requests, and here's a response, right? 200 OK. Everything went fine. The server is example server. There's 5 bytes of contents, and here's the type of the content. It's plain text. Hello. 5 bytes, plain context. That's how this is what HTTP 1 looks like. So you set that verb, or typically it depends on what kind of transfer you want to do. By default, curl makes a GET request. You can ask for a head request. It doesn't provide any body at all, just headers, no body. Just give me just the head. That's just the top part, the headers. Or you can send a post, which contains some data you send to the server, to that resource. And we have then the -D or -F options. And we can upload data, which is the put. Replace the resource with this. You can actually send any verb with curl. They're also sometimes abused. Sometimes you can switch them around a little bit, and you can tell curl to use whatever. It's a little bit flexible, and HTTP is not a very, you can implement it in many different ways. You don't have to be very strict in following it. So sometimes you need to customize it a little bit, and then you use this -X whatever, so you can set whatever. Typically, and you will hear me say that a lot in many circumstances, but typically you don't want to use -X, and you absolutely don't want to set it to get, head, post, or put. But because if you do that, you're typically wrong. So avoid it. So when you want to get HTTP headers in the terminal, you get them bolded. For example, and you're right, and you get the linkified location URLs like this. If you get the headers from curl.sc like this, you get them in bold. And let me show you what it looks like if I bring up my terminal. So basically, as the example slide shows you, if I do go to curl, and if I there's no scheme here. There's just the scheme, so I can do this, and you see the header names are in bold. I can also go to https:// and then I got a HTTP2 instead of HTTP1, so all the headers are now lowercase, but they're also all bold. And a fun part then is the if I do the one on HTTP, I get a location, and as you can see, that gets underlined when I move the mouse over it because it gets linkified. So if you have the right terminal, curl will use this as sort of a magic escape code, so it'll turn this into a proper link, and the link should also work even when the URL is relative here. The -I here is actually then a head, so it makes a head request. So it's the same thing. So it's a capital I. I'm sort of a bit damaged. I always use the short version, of course, because I've done this a bazillion times. But so that's what you do. And if you wanted to instead send a post to the server, I could send a post data, and then it would send these 9 bytes to the server. Boom. This server doesn't care about that, so it didn't do anything. It just returned a redirect, right? So anyway, response codes, that's the number 200 in here. That's typically a return code saying what kind of success it got back. 200 means fine. You get a 404 if it means a file not found. There's a whole plethora of them. You can read up on what they mean. Important here is curl normally doesn't care about the response code. Basically, if you get a 200 OK is back, or you get a 404 file not found, it's the same thing for curl. It's actually a successful transfer, and that people have a little bit hard time to grasp that at times. But if you ask for a file that doesn't exist, it's still a fine transfer for curl. And I'll show you, for example, what that means. Here's the curl website. https://curl. We want to get a page somewhere, and if I would get the I could get for example, the downloaded curl before, right? Curl 8201 tar, different extension this time. And if I download this, it works fine, and I got it. But even then, even if I yada, not likely to exist on the server, right? Because this is not actually a curl download. I just mistyped. This is a typo here in the URL, and I downloaded it. Look, it worked, and it worked. Why? Because the transfer went fine. But and I save this now as curl yada yada in my directory here. So if I look at curl yada yada, that says I think 6,156 bytes, and it probably says something about 404 file not found, blah blah, whatever you hoped you were going to get when. So it's a 404 page basically, but successfully retrieved, so it worked. So curl did not return an error. It said fine, it worked. Keep that in mind. And if you don't want that to happen, you can use dash lowercase f. And then it is a dash fail actually in the long one. Then if you do the same thing with that, like this, if you would do the yada yada and like that, and you dash fail instead, you instead get an error, because now you told curl to care about it. Normally it does not care about it. And if you want to do more fancy things, remember I told you about this write out option -w. So you can actually also, if you want to, output the response code, for example, afterwards, like this. And I can show you that as well, of course. So if I, for example, did this and I wanted to, when I'm done with the transfer, show me response code. Show me the response code after the transfer is completed. There. So to maybe combine with another option, silent, shut up about the progress meter, and just show me the response code 404. It tells me that the transfer maybe was not to my satisfaction, or maybe I just wanted to test the error page and then it worked. So that's fun stuff. And there's also, of course, response headers. So in all responses you get from an HTTP, you get headers back. And of course, you can see them with using just the verbose option. I showed you -I, which makes a head. You can also use the lowercase I, which means include headers in the response. Sometimes not what you want. You can also use actually -D to dump headers in a separate file. So there are many different ways. The response headers also describe the body and or the transfer. So the headers in a response, they have different responsibilities, and they're sort of depending on what they're there for. You can see the difference, but they actually can both describe the resource and they can describe the transfer. Right, you can save them with -D in a separate file name if you want to save the header somewhere else. When you use the other HTTP versions than 1, they will sort of still look the same as they did with 1. So 1, 2, 3, they look the same. Even if they actually don't look the same over the wire, we make them look the same for you. In response bodies, that's the response coming back from the server when you ask for something. That's sort of the data, the payload. So it usually has a content length. It can have a content length. It can also be done in many different other ways, like in chunked encoding, basically chunk. Then you don't know ahead of time how big it is, just a series of chunks coming. And with HTTP 2 and 3, basically they can send data without chunking and without telling the size ahead of time, and then it just tells us when the data is done. You can also ask for data to be compressed. So basically, if you go back to my little example here, let's ask for a proper download again. We want to get this download, the latest curl version. I can add compressed to this command line. And now when doing this, I will ask the server, so if you can, please compress the data when you send it to me. And when I receive this, it'll automatically uncompress the data. And this actually works for anything, right? So I can do like this if I want to get the web page from the main page from the site, save it to index.html, but ask for it to get delivered compressed, which basically then saves data, right? It gets smaller, gets compressed over the wire, and then curl will automatically uncompress it in my end. So if I do like this, I ask for it compressed, and this time I got 3,000 bytes, right? And it's still 8,500 bytes when uncompressed. So we saved 5K from the transfer. Neat. Of course, in many cases you actually want that by default, more or less. And of course, remember, saving things, you can save it to the lowercase o and the file name, or uppercase O and then picks the name from the URL. There's this authentication in HTTP, which basically means credential, right? So you want to prove that you have the right to get stuff. I mean, usually these days when you do web logins and things on the web, it's not done with HTTP authentication. Mostly because people want to control the login experience and things like that. So we will get to that in a second. But usually HTTP authentication, it's pretty much like when you get a 401 back from a server, it means I want authentication. If it's a proxy, it returns 407. And it contains this. A server would then include this header and says, I can speak one of these different authentication methods. And then you would use one of those. And curl supports several of them. And you use authentication like you've done with all the other protocols I mentioned already with the -u user : password. Typically, maybe you would use the --any auth, which says use the authentication that you know. It lets curl pick the best one out of the ones the server says it speaks. If curl can do one of them, usually it can. Otherwise, you can also say, no, I want to use this specific authentication method, basic, digest, and tlm, negotiate. You can also get data. You want to have, look at the fun picture, a piece of the pie. You just want to get a little piece of a remote resource. A really big file, you just want the first snippet out of it. Or you want a range, index 5 from byte 500 to byte 999 out of file.txt. And just get that written, in this case, to standard output. This has the unfortunate downside that the server can ignore your request and just deliver the entire thing anyway. You just wanted those 500 bytes, but you got those megabytes from the server. You can also use this resume function, which is just a slight variation of doing the same thing. You can resume my transfer from this index. And as I mentioned, there are different versions of HTTP. Started out, HTTP was sort of created, sometimes called invented, in the 90s, right? In the early 90s or maybe late 80s. So anyway, the first specification of HTTP was called HTTP 1.0, and that was in 1996 or 7, I want to say. That was HTTP 1. And sometimes then when people talk about what existed before that standard, before HTTP 1, people call that time the HTTP 0.9. So therefore we have the 0.9 and we have 1.0, we have 1.1, we have 2, and we have 3. Curl can speak all of them. HTTP 3 is still experimental, so usually people don't have that enabled yet. So maybe in your version of curl you cannot enable HTTP 3 just yet. Hopefully we can do that soon. And generally you don't need to care about HTTP version if you just want to get or send stuff over HTTP, right? Curl will just negotiate that for you and you can just ignore it. It'll work the same way, still act the same way. It's different over the wire. It's made sort of so that the users shouldn't have to care. If you want to let your curl speak 0.9, you have to tell it to allow it, because it's a bit of a weirdo thing when a server responds back with a 0.9. It opens up for different mistakes and problems, so we don't want to do that unless you actually want to and you know what you're doing. If you want to go with one of those ancient versions, I said mid-90s protocol, H.0, I want to go with that, ask curl to do that. Otherwise, H.1.1 is a general default for HTTP. If you go with FTPS, curl will try to go to HTTP2 if it can, negotiate that in the handshake. And there's this experimental HTTP3 that if you build with HTTP3 support, you have to enable it or ask for it with this option. It won't use that otherwise. And how do you know which server, which version the server supports? You can ask it, or you can, again, the write out option has that info in the variable called HTTP version. So if you connect to the server, ditch the output, just want to know the HTTP version, it's there in the write out option. And if you happen to run an HTTP3 enabled curl, you can actually also allow it to try HTTP3, and in this case you will get 1.0, 1.1, 2, or 3, depending on what version this particular server speaks. In this exact case, with the curl.sc server, it supports HTTP3, so it should say 3 if you have a 3 enabled curl. Otherwise, it should say 2 if you have a 2 enabled curl. And if you don't, you really should have. Otherwise, it'll say 1.1. When you do requests to a remote resource, you want to get a resource. Back to my cron job, you want to get something every day or every hour, every week. You can do the transfer maybe only if it's newer than a particular timestamp, right? What about if the server is newer than, if it's created or it has a modified time that is newer than September 1st, 2021? Only then return it. If it's not newer, it'll return a 304 response code and no body. Or you can reverse the condition. Only if it's older than that, give me it. And then you just prefix the date with a dash, a single minus there. You can also even do if it's newer than the local file that I happen to have here. So if it's new and if it's then a file name, it'll extract the date, the timestamp from that file, your local file, and use that as the time condition in the request. And this is usually then also very neatly combined with if you use the -r option called the --remote time, I think, in the long version. If you use that option, when you get a file, it'll use that remote file stamp and put it on your local file. So if you're getting a file that was made in 2021 on September 1st and you use -r, your local file will also get that timestamp, September 1, 2021. Which is convenient if you want to do it like one of these time-based things for your next request, checking if the file has updated. Is it newer than what I got the last time? Then similarly, you can also do e-tags. And e-tags is another way to do conditional things. Only get the data again if it's different than the last time. You basically do this, save the e-tag for this resource this time. And your e-tag saved it into this file. In this case, we call the file remember. So if I get this file, remember the e-tag here. And then I get it again tomorrow. Only get it if it's different than what I got yesterday, right? E-tag save, e-tag compare. So as long as it's the same that I already have, don't get it again. What if it's a super huge file? I don't want to get it again until I need to. So as long as it's the same. And of course, you then want to do the convenient thing. So if it does update, you want to save the new update, right? So remember the new one if it's different. So only update if it's different. Get the file if it's different. Update the e-tag if you actually do download it. Very convenient thing for automated things. Your cron job that you do every day, every hour, every week, every year. It's no need to re-download it again if it's the same thing as it was the last time, because you already have it. And of course, I mentioned TLS 24 bazillion times in this talk already, but HTTPS is HTTP with TLS for security, right? So there's really no difference in use typically. You just add that S and you have TLS and everything is fine and dandy. It'll automatically negotiate whatever for you, and even try HTTP2 by default. If it can, it'll sort of ask the server if it can. If it doesn't, it'll stick to 1.1. And HTTP3, the newest version of HTTP, will only ever be done over HTTPS, because there is no clear text version of HTTP3. It will only be done over HTTPS. So if you ever want to do HTTP3, you have to make sure that you speak HTTPS, because otherwise you don't have to even try it, because it won't use it. It can't. So anyway, going forward, HTTP post, that's a way to send data to your server, right? And sending data to a server, it's really, you can send anything. There's no limitation here. You can send a single byte, a bazillion number of bytes, and the bytes can be in any order, in any form. We don't know what it is. Could be, code, even use film. We don't know. We don't care. It's just data, bytes over the wire. Typically, if you want to do it easy, you send it with the -d option, also called --data in the long form. Basically, here's a string of data that you want to send to the server. It is often, as I mentioned already before, done in this name equals value pairs separated by ampersands. So in this case, name is admin, shoe size is 12. It's a standard sort of way to provide it. Well, I shouldn't say standard, but it's a common way to do it. So you will see that this is very, very, very commonly used everywhere. So you just send this data to the server. You can also split it up in multiple -ds, and cURL will put it together automatically for you, so that you don't have to think about it. It makes it nicer perhaps when you create command lines or write scripts. You don't have to sort of mush everything together if you don't want to. Or you can read the data off a file name, so you don't have to put it all in the command line. We could put the data to send in a file, or read it from standard in. Or you can even sort of make sure that if you in this third example, when reading from a file name, you have to specify that by an @ sign in the beginning, @ file name. Someone then pointed out to me that what if you want to send data that starts with that @ symbol? So then we had to create the option called data raw that doesn't read from a file ever, so you can send, it can begin with an @ symbol without a problem. That's how things are. And if you want to actually read everything from a file strictly, including all new lines exactly as they are, you can use the data binary option. So a lot of different ways to send data. More things about posting. Posting is a big part of cURL, right? It's a very popular, common thing. Sending data to a server. It's fun, it's good, it's convenient. And when you send data with -d, it sets a content type. The content type is supposed to describe whatever are you sending. Usually, many servers don't care about the content type. It doesn't matter what the content type is. They just expect some data to come, and they will sort of assume that the client is sending the data in the right way. So that's but cURL sets this content type because it's this sort of default way to send post. XWWW form URL encoded. A hint about that the data is supposed to be URL encoded. But you can change that, right? Just set whatever content type you want. And you can do that as a test if you want to your service and see if they care about it or not. And you'll see that most servers will not care about it. Some will. And of course, recently, within the last decade, I don't remember, 5 years ago, I don't run, we added also extra new support as a sort of an alias to -d, data to better send JSON. So if you want to send JSON like this, here's name Daniel in a JSON style. I'm not really a JSON guy, but so I write this sort of JSON looking things and I say it's JSON. So come on. It's JSON, right? So if you do this, it puts this data and it says that it's JSON. It sets the right headers and makes it look proper JSON to the server. And you can do the same thing there. You can read the JSON from a file from disk and send it to the server, and you can send it, standard input as a JSON and so on. And it sets this content type header and an accept header, because it turns out that quite a lot of JSON receiving ends, at least then checks these content types and accepts. So basically just a convenient shortcut to send JSON. You could send JSON fine before that, but now it's even easier because it's less options to use. Right, and if you want to create JSON to send, I can also only encourage you to try out the command line tool called JO as a sort of a companion tool to JQ, JSON output maybe. I don't know. It makes it easier to create a JSON object like this on the command line. Just JO, and I don't know JO either, but this creates a JSON object, passes it on to curl. Curl reads the JSON from standard input, and you see the @ thing, and sends the JSON with the right headers and everything to the server. Really neat. And if you want to then the other way around, when you get JSON back from the server, sometimes or perhaps often, you send JSON to the server, you get JSON back, and you want to parse that. You of course know that there's this awesome tool called JQ that is a perfect tool for you to parse JSON with and pretty print it and extract it and do whatever. It's a very powerful tool. So if you get JSON back, pipe it into JQ, and then you of course can do the magic triplet. Use JO, create a JSON, send it to curl, send it to the server, get JSON back, pass it on to the JQ. Awesome set. Success, win, profit, everything. So when you do this, these are usually URL, as I mentioned before, the default is the URL encoded content types. So usually you send stuff URL encoded. URL encoded meaning you encode everything that is part of the data that can't be part of URL. You encode it as percent encoding, like percent 2 digits, which is the ASCII or byte number for the byte. So basically, if you want to send name John Doe, parenthesis junior, with some spaces and some parentheses and stuff here, and you want it to be URL encoded and you want to post it to the server, then we have the data URL encode option that does it for you. It'll then send this blob over to the server because it'll URL encode all the stuff that's not safe to put in a URL, which means in this case the spaces and the parentheses. So, and you see they get encoded to their URL encoded versions, which is a percentage sign and 2-digit hexadecimal bytecode. And you can do this in several different versions, as you can encode content, and you can sort of encode the name, and you can read the content from a file, and you can URL encode contents directly from a file, and so on. So it's a powerful thing. It helps you send data URL encoded, in particular from the command line when you maybe get data that is not properly URL encoded and you need to send it URL encoded. You could do this. You can also then create everything for a post and then convert it to a GET. This is super crazy, but if you do like this, you want to send a post with the admin and shoe size. This is an example I used from before, right? But convert it into a GET and put that data, instead of doing a post, make it a query part in the URL. So basically you add --get and it'll then use that as a query part in the URL and make a GET instead, as then the request will look like this. It's a super crazy thing. Basically, don't make it a post, get the data and convert it into query parts instead, and instead make it a GET with that query. I really recommend you using URL query instead. This --get thing is an older invention created a long time ago. I think URL query is a much more convenient way and a better way to do the building the query part, and more powerful actually too. When sending data to a server over HTTP, actually over HTTP 1.1, there's this concept of called expect 100 continue. Basically, it's a way to allow the server to, because with HTTP 1.1, when you start to send data, there's no way to really stop sending the data without sort of killing the connection. So if you want to send a lot of data to the server, you want to give the server a way to say, wait a minute, we don't want it, stop, don't send me any data, you're not allowed to until blah blah blah, or something like that. So there's this notion that you can send expect 100 continue, which asks the server to say, please tell me everything is okay, and then I will continue. So, and curl will use this. If you're telling curl to upload something that is larger than 1 megabyte, it's actually in some other cases as well. But basically, if you're going to send a lot of data to the server, curl will add this header. If we add this header, the server is supposed to tell you, go ahead. Sometimes the server doesn't know about this. He'll just don't say anything. So then curl will wait a while. Didn't get any thumbs up. I will go ahead anyway. So it waits for a 100 to say, go ahead. If it waits for a while, and if it doesn't get a go ahead, it will go ahead anyway. Sometimes, if you know that it won't get that, you can skip it. Basically, ask curl to don't use that header because we will not get the 100 continue. So you can avoid wasting time. You can also send data without knowing the size ahead of time. We can basically force curl to send a chunked encoding data for 1.1 server. It's basically it's a way to send data by just chunk without sending the total size ahead of time. A convenient way to do it sometimes, and especially if you send data from standard input or something when you don't actually know the data. So basically, when a browser sends a post, it does that as a sort of a response to a form tag in HTML typically. And a post is then sort of filling in the form and sending the form results back to the server. That's the typical way to do a post, or that's how browsers do post. And when they do that, they include all the types, the sort of in HTML there's input tags, and they can be type hidden, so they're not actually visible in the web page, but they're data that are sent to the server anyway. And you just provide all the input fields like this when you want to look like you're submitting a form as a browser. Right, and you need to check then, because there's a action equals target in the form tag in the HTML. It actually says what's the target to send the post to. And again, copy as curl is really your friend. Check what your browser does when you submit a form and you want to do the same form with curl. Do the copy as curl and check what kind of request the browser did, and then go from there. A post can also be more complicated. You can send a more formatted, more sort of structural way to send data to the server. I call it a multi-part form post. That sends a number of parts in a structured way to the server. It has a different content type. It says multi-part form data. It's a number of series of parts, one or more. It can actually be an unlimited number of parts, usually a low number, but there's no restriction to the number. And each part has a name. It has its own set of headers, file name, and more. And they're separated by MIME boundaries. I'll show you how it looks like. Basically, like this. There's first a MIME boundary. That's the line with dashes and a random number. It's basically just a random thing. It's a random thing. It's a separator. And then there are headers for this part. In this case, it says name equals person. And then there's content for this person, anonymous. That's the content for this part. And then a new boundary, so next part starts, and that's new part. It says name secret, and that has a file name because it's a file attachment, basically. It's a file name. So it has a content type, text plain. And then there's contents of that file. And then there's another MIME boundary. And this MIME boundary has actually ends with 2 dashes, which means it's the final one. So this is a two-part multi-part form post. So this is how it looks like, and this is typically how you do file uploads with browsers, or whenever you get the file selector to select an image or a file or something, you upload it. That's how a browser does it, and that's how you can do it with curl as well. And if you want to do it with curl, you use the -F option, and you do sort of specify what kind of content for each part you want to upload. So, and you do as many parts as you want. You can, I mean, there's no limit to how many you do them. So it could be that simple. Person is anonymous. It could be name is Daniel. It could be name reading the content from a file. It could be some sort of faking a file upload. It's sort of you get the name as a file here, and it'll set it as a file name in the multipart form, so it looks like one of those uploaded file things. And you can set a different file name in the upload or sort of in the post than that you actually use to read from, and you can set a different content type, and there's a plethora of different alternative options here. Basically this is how to sort of do the same things as the browsers do when they get this enc type multipart form data thing in the form tag. Very convenient and powerful. So when do you use -d or -f? Two different kinds of posts, right? Different contents, different ways to do them. Both sends HTTP posts, both work over any HTTP version, and both sort of can fill in forms. The form tag uses different, I mean, you can see in the form tag which different kind the server expects. And you can rarely just pick anyone you want. It's typically the server who decides, because the server has, code in the other end that's check stuff and parses and decodes stuff, and it usually doesn't, handle either or. It'll want one of them, and you need to pick the one that it wants for success, at least. And maybe this is not news to anyone, but HTTP also has this redirect concept. So basically, instead of returning the data right now, it says it actually is not here, it's over there. And it's a 30 something response code, in this case a 301, and it's a location header in there. So the location says it's actually over there now. Go look there. And there are different response codes. The different response codes are different time scopes, and you act differently. You modify the method differently when you follow the redirect. So the response code is actually, it matters, but usually you don't have to think about it. If you just ask curl to get this resource, and you get a location, like you get a response code 301 back, you just got it back. If you add this -- location option, that's capital L, you'll ask curl to follow that redirect over to follow the location wherever it points, and it'll do that. So in this case, very easy. This is this web page, curl capital L curl.se, right? And this is using HTTP, and since the site says, if you're on HTTP, redirect to the FTPS version. So if you see contents here now, we see that it actually followed the redirect. And if we use -v, we can, and if we can even, hide the output, just use the verbose output. And then we scroll up a little bit, and then we can see that it first connected to the plain text version. It got a new location, and then it got blah blah blah, issue another request to this URL, and then got the other one. And of course you can set a maximum number of redirects to follow, because sometimes it'll end up in a loop, so it'll just never stop following redirects. So it can be convenient to set the max number. And if you're using credentials or sending a username, like username password, typically that password and username will not be passed on to other host names other than the one used in the first request. But sometimes you want it to be transferred to the ones you're following. Then you use this location trusted instead. And you really want to avoid the $X. I mentioned this before, but in particular in combination with location, you will get sad faces all over if you try that. It's not going to be fun. So avoid $X. And when you want to play with a request, of course, you can do all sorts of fun things, but you should remember that curl tries to be sensible and basic by default. If you use curl and the URL, it makes a GET by default. You don't ask for get to be used. It's just there. If you use curl -d and send in post, it'll do a post by default. You don't have to ask for it. But it also means that it'll be in sort of a no frills version. So if you want to add bells and whistles, you have to tell curl to add stuff. You can modify along you can modify the method with request. If you want to send a delete method, do -- request delete, and it'll send a delete instead of a get by default. You can change headers with the -- header option. You can add headers, you can change headers, you can remove headers, and you can send blank headers with -- header. That's the short version is called uppercase capital H, right? Like this. Send this example here includes the new header curl master very soon to this in this request. Very useful. Maybe not, but who knows? You could actually add a useful header. But you can also do like this. This is, I mean, by default curl will send the host header, but if you set your own host header, you will replace the one that curl would use by default. So by setting one that curl would use, you override it and you say, hey, use my version instead. I know better. This is going to be fun. And you can provide a completely wrong one. Or you can do it like this. If you don't provide any content on the right side of the colon, like this, user agent colon, you tell curl to don't use your own version. In fact, don't use any at all. It just remove this header from the default request. So it'll send the same request except this particular header. And you can of course combine everything of this in the same request if you want to. And if you use this magic little trick and use a semicolon instead of a colon, basically user agent semicolon, it means send this header but with a blank content on the other side of the colon. So basically no value for this header, which is rather unusual, but still you can do it. It's fun. And you can modify the request in other ways. For example, the target is called the thing, but when you do a web HTTP request, basically what you're asking for is a path plus query, right? In this case, /user/profile !shoe size equal 12. That's the target. It comes from the URL, right? That's the target. What's the ask? You ask the server for this, and you can, if you want to, you can set that target to something more crazy than than you can set in the URL. For example, if you want to send a request target that is just an asterisk, it's not possible to actually set just an asterisk in the URL because it's always a slash in there. So if you want to send options asterisk to this server, here's how you do it. There's also some convenient shortcuts, like if you want to set user agent, you don't have to do uppercase H setting header this user agent and then set a string. It even has a short version called -A. You can set a referrer, and referrer is another header. Yes, it's spelled wrong, but it's a way to tell when you get a resource, you can tell I came from this other place. The other place redirected me here when I got, or sort of I followed a link from there. Usually sort of maybe privacy leaks, but so use it with care. But that's at least a convenient thing. And again, copy as curl, and you can sort of learn how the browser would do it, and then edit that line and have fun. Put is the more uploady thing. Pretty much it's HTTP's lingo to replace a remote resource, right? Put my file here remotely, the entire file over there. Post is more sending data to another place. Put is sending, sort of replacing the file over there. And you do the upload as you do without all the other protocols with curl like this. You can do it from standard in. You can put the file, and if the file name is not at the end of the URL, like in this case, you see the URL doesn't end with the file name, it will put the local file name on the end of the URL. You can even do this globbing thing with upload. So if you want to upload 1,000 images like this in a single command line, have a go at it, and it'll upload 1,000 images to as puts. And well, yeah, you can do that with other kind of globbings as well. And if you want to do fancy, you want to go crazy, you can use that uppercase X, as I've told you not to. But if you want to do provide the data to put with -d, which otherwise would do a default to post. You can actually change the post to put like this. So you can be creative with curl, no worries. So okay, when you work with your random servers these days, you also want to speak cookies, right? Cookies is a way for a server to send key value pairs to the client. You access something on the server, and the server tells the client, save this, and the client will send it back on subsequent requests on some conditions, right? When the properties match. And curl supports this, of course. Each cookie has an expiration date, or end of session. So it lives for a while, or end of session. There's also a session is kind of not defined. What is a session? Typically, a session ends when the user closes the browser. But these days, I bet there's a lot of browsers that never close. So basically, those sessions never ends. But anyway, that's a cookie session. It's a little bit weird. But ignore that. But that's just how it. Don't ignore it, but just keep it in mind. So when you run a curl command line, right, that sort of mimics a browser or does a lot of things, when does the session end? It doesn't really end, right? There's no session for when you do 22 different curl command lines. But maybe you should still be able to tell curl let's mimic a browser close, basically. I'll get to it. You'll understand. It's not that complicated. So basically, you can tell curl to send specific cookie names with values because it's fun. Usually, you don't actually know exactly what to send, but maybe you want to send the cookie that calls "My name is Daniel. I talk a lot" to the example. Yes, easy peasy. Just specific cookie. That's rarely what you want to do, but you can do that, and often that's exactly how you get the command line from copy as curl, because it will save exactly the cookie it would send you. It would have sent. It's rarely the way you want it, because you actually rather wanted to send the cookie contents that you got in a previous request. Not this exactly every time, but the last one, because it's going to be dynamically updated, right? So usually you want to do it like this. First, of course, curl ignores cookies by default. So you want to sort of enable cookies. And you do that, we call it cookie engine. Sort of enable it. And you enable it by, for example, specify a file to read from or use a blank string. And you can use the -b again here. So by doing this, you enable the cookie engine. And in this case, of course, it doesn't really matter, but you just get one file. You don't save the cookies anywhere, so it doesn't matter if you enable cookies here. But if you would follow redirects here, then it's a good thing, because then you enable redirects, enable cookies, and then if the first page sets cookies, it redirects to the second page, and curl will then send cookies in the second request if they should be sent. And the cookie engine then keeps those cookies in memory related to this, of course, and it forgets cookies automatically then that expires, if any expires. I mean, they set a time, right? So if the process is slow and there's a short expiration time, they will expire while curl handles them. So sort of it follows the rules, it abides by the rules, it does what it should do for cookies. And of course, it only sends them back according to the rules, because that's how cookies work, right? They're defined. And when you want to save them, curl saves them. We save them in what we call a cookie jar. That's the storage we save cookies in. And when curl exits, when it's done, you can ask curl, save everything, save all the cookies in the cookie jar. I'm getting I've talked a lot now. So when curl is done, save all the cookies in the cookie jar, and you tell curl to do that with the -c option. So basically like this, in this example, follow redirects, enable the cookie engine by this default read nothing, and then save at the end of the session, save everything to cookies.txt if there is anything to save. If there were no cookies set, it will not save anything. It will just be a blank file. And I just want to emphasize that since -b and -c, they both take file names. So you can make it read from one file and write to another file. Or they could be the same file. Usually they're the same file. You don't have to have them the same file. I just wanted to sort of remember that. So usually when you play around with this, you set -b and -c to the same file name, because then it reads the old cookies from the file. If it updates them, it'll rewrite the new ones, or the current new set to the file back again, just over and over. So you can have that in your cron job and your scripts, and like this, sort of do this every time, and he'll just maintain the cookie state correctly in the cookies.txt file. It uses the so-called Netscape cookie format. We call it like that because Netscape, the browser, actually sort of created that cookie file format once in the 90s. It was used for a while by other browsers, but the browsers then switched away from that. But curl did not switch away from that. So curl still uses that. It's a very simple text-based format where each cookie is a single line with tab separations. And okay, and as I mentioned, there are sessions then. So some cookies are stored sort of for a session. They don't have any specific expiration date. They live for a session. So you have to tell curl when the session ends. When does a session ends? In curl, you don't actually tell when the session ends. You tell when there's a new session. So we have this new session. We have this option called --junk session cookies. I believe could be a short option for that. Yeah, the -J. It basically says load all cookies again, with -b, yes, normally, but throw away all session cookies because the session is now gone. This is a new one. So all the ones that we already have, they are part of the past session. They're gone. Throw them out. This is, I mean, you actually rarely use this, but this is a way to sort of clean up the session cookies. Okay, I told you before that HTTP versions are rarely that much to care about. It'll just be used by default and sort of automatically. And version 2 changed how things are sent over the wire, but it's typically curl doesn't really show that. It tries to hide it. It converts everything and makes it look like HTTP1 as it looked like before. It tries to negotiate HTTP2 for all HTTPS, and you can make it use HTTP2 or try to use HTTP2 even for HTTP transfers if you just ask it to. It's sometimes a recipe for disaster, so maybe not go overboard and do it too much, basically because of how the internet and servers work, not because of what curl does. And if you have the opportunity to use HTTP2, the good part with HTTP2 is that it can do multiplex transfers, so meaning it can do multiple transfers over the same connection. So if you do multiplex transfers using the capital Z, many transfers at the same time, if you use HTTP2, it might actually use multiplex transfers. So it doesn't have to, even when you do 50 parallel transfers, it doesn't have to do 50 parallel connections. It can do much fewer connections, hopefully, possibly, in the ideal case. And HTTP3, being the new kid in town, then it's still experimental, so you don't have it enabled by default. You have to enable it in your build. Most people won't do it. We discourage people from using it in production. It's changed again how it's done over the wire, right? So it's now done over QUIC. It's not TCP, it's not TLS, it's now QUIC. It's a new transport protocol done over UDP. It replaces TCP and TLS. It's a completely new thing. Everything is different. It's even more encrypted, hides more things over the wire. But again, the fact that it's so different over the wire and different in many ways, it's sort of hidden to the users of the curl tool. So you don't have to care about it. It's only for the HTTPS I mentioned before, and you can ask curl to use HTTP3 or attempt to use HTTP3 if you use this option --HTTP3. And we have this fun race when you use this. So HTTP3 races against the older HTTP versions, and you pick the winner. You remember I mentioned the happy eyeballs thing when we sort of raise IPv4 versus IPv6 when we do a connection. So we had the white IPv6 car and the red IPv4 car, and the one that sort of wins the race gets the connection. And now when we ask for HTTP3, we add another dimension to this, and let me show you. Oh, right, I forgot to mention that too. So if you do this, again, multiplexed transfers work with HTTP3. So if you use parallel transfers, it could do multiplexed transfers. Same as for HTTP2, but different connections. So HTTP3 racing, fun stuff. So then we have this cURL client laptop again. It wants to talk to cURL.sc. It resolves the hostname from the DNS. It's get that huge list of IP addresses. As I mentioned, 8 IPv6 addresses, 4 IPv4 addresses, and it then starts the HTTP3 IPv6 car, and it gets then all the IPv6 addresses to try to do HTTP3, which then means over quick for IPv6 to this, and with a slight delay, we start the HTTP3 IPv4 car, which gets a set of IPv4 addresses to try to set up quick to these addresses, and again then slightly after delayed a little bit more, we set up the HTTP2 IPv6 attempt, and then if slightly after that we set up the HTTP2 IPv4 attempt. So the IPv4 attempts here used IPv4 addresses, and the IPv6 attempts used IPv6 addresses. And the first who wins then wins, and all the ones that sort of didn't win, they will get discarded and thrown away. It gives H3 a small edge, because in this case you asked for HTTP3 support, right? So you wanted it to be HTTP3, but in case of HTTP3 gets problems, it's slow, it's bad, the HTTP3 cars will not succeed, and then the fastest HTTP2 car will win instead. And in this case, I mentioned HTTP2 cars here because HTTP2 in this case is a negotiation between H1 and H2. So it'll pick H1 or H2 depending on what the server can speak. Fun stuff. Rather complicated, but it works really well in reality, and it makes so that curl picks the one that works and is the fastest to answer. In HTTP we also have other fun things, getting really into the weeds of the HTTP details. We have this, I like this finger pointing over there because this is the alt service. This same service also exists over there. It's an alternative service over there. It's like that finger pointing. So it's over there for a certain number of seconds into the future, and it's alt service response header. And this is how the server can say that I also exist over here, possibly a different version, different source, place, host name, and so on. It has an expiry time, and it's only over HTTPS, but curl can then save these alternatives, and you can ask curl to use these alternatives in your follow-up request. So basically, save the alternatives now, do a second request, use the alternatives, and then you can go to the sort of like this. Save the alternatives. If there are alternatives this time, use them. So then you might not go to the same server anymore. You could go to a completely different host name because example.com told us that there's an alternative that it wants us to use. Pretty neat thing. This is the official way to switch to HTTP3. That's how the standards mandate things to do. So once you have HTTP3 support in curl, you might want to do it this way. It's a text-based readable file. You can read it, you can edit it, you can do whatever you want. You can also a slight variation of the old service is you can say is the HSTS thing, which is this HTTP strict transport security, which is a way for the server to tell the client, to tell curl, don't contact me over clear text HTTP anymore for this amount of time into the future. Basically, it's a way to So as I showed you before, how curl, when I accessed curl.sc with HTTP being an unauthenticated, insecure protocol, we want to avoid going to using clear text protocols. So we don't want to go with a clear text protocol to have that upgraded to HTTPS, because that HTTP face is an insecure, weak point, right? So once we've done that once, we can save the HSTS data that says we should never, for this host name, we should never speak clear text again until this expires. And the service says this with this strict transport security response header, and curl will save that in a file if you ask it to, and then you can tell curl to use it, and then it'll, in this case, if we had saved that HSTS data for this example.com site, and we used its HSTS cache, it will not go to the over clear text again. It'll then automatically internally switch to the HTTPS version, thus avoiding clear text, thus avoiding the insecure part, and insecure sort of avoiding the attack risk or the vulnerable point in time where someone could eavesdrop or interfere or do something bad. And that again is a text-based file that curl saves and reads data back from. Right. We're on 3.5 hours, so slightly over time, but as you can see here down at the bottom right, we're only 12 slides away from the end. I hope you all are hydrated, awake, or so. So I think by reaching the end of HTTP, we also reach the end of the the super popular protocols that people use curl with. But I still wanted to get into FTP is still used by 2-digit percentage of users, at least when I asked them. So I wanted to get into some details with FTP. FTP being a little bit of a legacy protocol, it's not used much. It's sort of possibly slowly dying and dwindling away, but still. First, I want to emphasize, because this is so common, FTPS is not SFTP. It's the same letters in a different order, but they're completely different. That's an apple, that's an orange. They are different. Do not confuse them. It actually matters in which order you put the letters. They're super different. One is done with TLS, one is done with SSH. They actually have basically nothing in common apart from them using the same letters in the acronym. It's not an acronym, is it? It's an abbreviation or whatever it is. Okay, first, what makes FTP funny, weird, strange, complicated, ugly, yet super annoying to work with? That is, it uses 2 connections to do transfers. Yes, 2. How does it do 2 connections and why? Well, basically, you set up, when you communicate, when you want to do a transfer, the curl connects to the FTP server. It first sets up a connection, and it speaks to the server, it authenticates, says hello, and you log in, and it communicates, and then it has to set up a second connection to do the actual transfer. And this second connection adds complications for everyone involved, for firewalls, for network setups, for there's an insecure part in it, so it's really, really difficult to manage. And so if that is not enough, you can do that second connection 2 different ways. You can do it in the active way or the passive way. So you can ask the server to connect to you, or you to connect to the server for that second transfer. The passive way is default, and it is default just because it's a higher chance of actually working, while active is even less of a chance to work, because I'll show you. It works like this. Look at that. The client curl laptop wants to talk to the FTP server. There's actually no FTP server on that host name, but it doesn't matter. It's an example. So when it does that, it curl connects over the network it sets up the control connection to the server, exactly like it does for any other protocol, TCP to the server over there. It actually does this. It's one of these I call ping pong protocols, because there's a lot of command and response several times back and forth to instruct the server to do things. And then to do the transfer, we either do set up the connection to the server or from the server, passive or active. And if we want the server to connect back to us, that is usually a problem because we have firewalls, routers, network equipment, whatever. It's really hard to allow the server to connect back to the client because the client is usually beyond a lot of fluffy networky stuff, so it's complicated. Anyway, both of them are complicated. And this FTP is basically always authenticated. Typically, cURL uses the default anonymous user and this password called ftp@example.com. But it doesn't matter if it's basically anonymous, right? But you set the user password like normal, like all the other protocols like this with cURL. If you want it to be authenticated, typically if you want to upload with FTP, you have to log in first. And you can do directory listings with FTP, and then you just add a trailing slash, because cURL doesn't really know what is a directory, what's the file name. If you don't add that trailing slash on the like this, there's a trailing slash here. It means that it's a directory, so cURL will make a directory listing out of this. But if you don't add the slash there, you just add with Linux, cURL thinks that's a file name, so it'll ask for that file to get transferred, which if it's actually a directory will just cause failure. And if you get a directory listing, you will notice that that's not a standardized look. It might look completely different on another server. It's just basically the server doing something to providing a human readable directory list, which is super annoying if you want to parse that directory with a machine. You can make it slightly better by asking for list only, which is a different command that you send to the server, which then only lists the file names in that directory, which makes it a little bit easier, but there's still lots of caveats, and FTP is a weird protocol in general. It's old and weird. And if you want to upload, again, cURL-T, you normally want to be have a user name and password, because servers rarely allow that for anonymous users. And again, you put the file name at the end and so on. With FTP, you can also append to the remote file, right? By adding --append, it will not only upload to that file on the other side, it will ask the server to append this local data to the remote file. And you can also create file directory sort of files on the remote side, so to create a directory hierarchy on the other side. So if you want to upload this and some of those directories are not existing remotely, try to create them when you do this upload operation. And of course, you want to go with TLS. Always go with the authenticated version of all the protocols, and then you add this SSL required to the command line. And then you can still keep using the FTP colon. It doesn't have a S in the URL scheme, right? But SSL required means that it's required to upgrade into TLS or fail. So you can be sure that it will still use FTPS, sort of the secure version. You can also use FTPS ://, but that's called to use implicit TLS, and that's actually rarely supported by servers. So you will see that you can try it with your server, but it will most likely fail, because that's another way to do it, more of a non-standard way. FTPS is even more problematic for firewalls and stateful firewalls. You know, the second connection coming back or going out is even more complicated, because in the FTPS case, when you have a encrypted control channel, no one can actually even then know when to open which ports and so on, which you could otherwise see in the FTP communication. But with FTPS, that's completely impossible. So it makes it even less likely to actually work. So FTPS, really difficult to get to work. In general, unless, I mean, within your networks and stuff, in more controlled environments, sure, but over the internet, complicated. And now we are on slide 149, and we are tired by now, right? I think we probably dropped about everyone in the chat, all the listeners are gone, but never mind. The future. First, of course, let me just remind you, get back to the facts that how do you get into this deeper. So cURL is of course everything sort of it's accumulated results and experience from a lot of time, a lot of experiments, a lot of testing, and a lot of user reports. So it's not always very easy to understand sort of everything, because it's sort of we did things from the beginning that maybe wasn't done in the most clever way, and so when we do things again, we make them in a better way, but then you might see that it's a little bit inconsistent. So maybe we added a feature back in the days, and now when we add this, roughly the next generation of the same thing, it's slightly different. And that's why, because of that, we learned things. We were all kids in the beginning. Now we understand a little bit more, so things are actually done better now. But then, and also thanks to the fact that we don't break behaviors, right? So we added that slightly crazy option 22 years ago. We still support that slightly crazy option today because we decided to keep the functionality, right? So that's one reason why some things are a little bit sort of maybe not ideal. But for the greater part of things are there, and also that's also we've been at it for a while, so we have 257 options now. So read the man page, read don't read it, search in them and find exactly what you want to read. Don't read everything, and tell us if you find any problems. And there's, of course, you can always go down to the source code, and you can always ask anyone if it doesn't help, if you don't find the problems. I mentioned everything curl. This is the URL, everything.curl.dev. It's really, I shouldn't say complete. It's never going to be complete, but I'm trying to cover pretty much all functionality. Pretty much sure everything I mentioned today in my super long video is detailed even more in the book. So if you didn't understand it, if my talk was incomprehensive or just go there and read a book, and if you still don't understand it, ask and we will clarify, and it will be better in the next commit. So I want to just go out and emphasize and sort of curl. We celebrated 25-year curls earlier this year. Of course, as I mentioned, curl was also just the third name of this project, so it actually existed before it was curl, but still curl, the name, the project, we didn't call it the curl project until it was named curl. So it's 25 years old. It's been growing and developed for 25 years. Its entire lifetime it has changed. There's a development speed that is increasing, still increasing after 25 years. So that combined with the fact that the internet doesn't really stop or slow down. I mean, it keeps changing. We don't do things today like we did even 5 years ago. So compared to 15 years ago, things are different. So curl needs to keep up. So if we want to do internet transfers with curl, we need to keep up and modifying and improving curl all the time, right? Because protocols and new ways of doing things change all the times. I mean, new versions, systems, concepts, everything changes. And I mean, there's no slowdown in general internet development, right? Or anything in the world. Things typically don't slow down really. It's, just things keep moving. So we have to keep up and keep moving with everything around us. So reasonably we will keep doing this, and we will keep expanding and adding stuff, and everything I've said today, I mean, there's a risk that it will feel outdated in a while, because we will keep adding things and keep changing things and improving things. And we do whatever we think we should do, right? I like to say that curl is just code, right? It's just code. We can make it do whatever we want. It's just code. So as long as we agree that this is the right thing to do, we can just do it. It's this easy. And curl is the result of a community and the wishes of a community, and we go forward to where we want it to go. And we have the luxury in the curl project that we are completely independent. We don't go by anyone's rules, right? We're not owned by a particular company. We're not even in any umbrella organization or anything. We can do whatever we want. So you can certainly affect what's next for curl. So I try to often to ask people, and you're always welcome to tell us what you think about whatever we're trying to do and whatever you want us to do, because it's helpful. We need to get everyone's, well, maybe not everyone's, but as many people as possible to get involved and tell us what's right and what's wrong, so that we get correct, get feedback for sort of to take the decisions. So you can certainly help and affect them and change things for what's going forward. And by that, we are at the end. I'm at 3 hours 38 minutes by my count, and it's been a while. Thank you for enduring this and for listening. I know there's plenty of people left in the chat at least, so not everyone has died just yet. So any questions in the chat room? Did I forget any important stuff? Did I stumble? Did I don't see any questions, but I'm going to just sit here and mention. I could go back to the beginning and say this was the Mastering the cURL command line session. I didn't find too many typos. I detected that I had missed animation on a few slides, but that was fine. I had a few typos, I think. But yeah, all in all, pretty good. So this was what I did get cram into this presentation. Yeah, so there's this joke about someone missing the beginning and asking if I could start over. But of course, I will make this available on YouTube. I'm going to stop the recording right now.